My name is Aleksandr Dunayeu, and I want to welcome you at Winter Data Meetup from EPAM Systems and Data Zen Community. And I want to pass my word to Aleg Roman, VP of Data Analytics of EPAM. Yeah, Aleg, please.
Thank you, Aleksandr. Hello, everyone. Let me do a quick intro, and I'm sure everyone is actually waiting for awesome content, which is still coming. Okay, so this event is powered by EPAM Data Practice. So people who are behind the Data Zen community, they are part of a data practice. And as you may all know already, we have a dedicated team of professionals which are focusing on anything related to data and analytics, data engineering, data science, machine learning, all cool tech behind data and data management. Also, as part of a practice, we have people who are specializing in certain domains, business domains and technical domains. And as you can see, there's some interesting numbers. If you guys don't know what data practice is, or you want to know more and you want to maybe join our practice, feel free to reach out to anyone who is a presenter in this community, and we can have a chat. Next slide, please. Okay. Also, I want to talk about global data and analytics trends, which we kind of can see these days. The answer depends on who you ask. If you go to the traditional source, like one of our agencies, like Forrester or Gartner, you can see some pretty cool kind of data points, like adaptable AI systems, metadata-driven data fabrics, decision-centric data analytics. All of that is true, but let's see if we can maybe simplify it a little bit more. How about we jump to the next slide? If we ask ChatGPT, funny enough, you see that there's some overlap. So again, we see the like in the data analytics, for instance, like advanced analytics is a trend of a days. Cloud-based analytics, I think ChatGPT is a bit late here. It's been a trend for last good 3 or 4 years. But if we go to the next slide, and if we ask EPAM data experts, and if we ask what are the global trends in the data analytics space, which we think will be the most impactful for our analysts and our engineers, then I would probably note these 3. So first of all, the rapid maturity of low-code or no-code tools. ChatGPT can be a good example. We basically get into the point where entry-level development tasks, including code generation, can be actually taken care by a tool. And that means that some of the demand for development workforce will be met by automation tools. At the same time, for us to stay relevant, we need to focus on expertise in actual technical and business domain. So instead of basically thinking of themselves as general data engineers, I think people start to think about data engineers in a certain space. In space, let's say, can be MDM, can be machine learning, or can be a specific business domain, like consumer and retail, or life science, and so on. Next thing is data governance. So data governance in a broad sense. We think that organizations, they will be focusing on developing frameworks which can help them to get actual value from the data and data analytics and the data assets. And that includes covering things like, well, traditional things like a data quality, data lineage, data catalogs, but also that means that people will be looking for new recipes, how to organize their teams around the data platforms, around the demand in the data space. And that means that knowledge and expertise in modern frameworks such as, like a data mesh, like product centricity, self-service analytics, will be more and more relevant going forward. And trend number 3, again, it's not the first year, it's been around for a couple of years, but it's getting more and more visible, is ML engineering and operation. So the services around AI ML, they're getting to the point where you don't need to be a PhD in data science or computational physics or applied mathematics to use it. So right now, they're available for every developer, every software engineer. And we will see more and more solutions which will be designed and built in a way that they're going to consume those services in shape and form of APIs or libraries to basically add more value to the standard application, standard software solutions. So it's no longer just AI/ML. Next slide, please. Now, community, specifically data Zen community and overall community, why is it important? The traditional, I've seen this slide in somewhere else, but it said intangible benefits. I disagree. I say this is the community is the way for us to deliver very tangible benefits. And if you look at the screenshot which I placed on the slide, some of you can maybe recall that this screenshot is taken from a keynote Arkady's speech on our stream conference just the other month. And the network is the keyword here. So community, such as the Data Zen and other communities, is the way for us to implement and run that network. So we are not relying on strict hierarchy as a large organization, but we still remain agile, nimble, and relevant to meet the business challenges. Let's move forward. Yep, I think this is the point where I need to pass talking to Aleksandr, who's going to talk more about Data Zen Community. And well, thank you very much for your attention.
Yeah, thank you very much, Aleg, for such introduction of EPAM data and communities. So yeah, I'm going to talk about Data Zen Community. If you haven't heard about us, so we are biggest data community in EPAM. So we unite more than 3,500 of data specialists. Yeah, one of our main goal is to create a global knowledge sharing platform for data experts and IT specialists in different forms. So we do interviews, tech talks, podcasts, news digests, articles. So if you haven't heard about us, you can find us in social networks, in YouTube, Spotify, LinkedIn. Yeah, next slide, please. And so today we have Winter Data Meetup. It's our biggest data meetup. So 2 days, 20 speakers from 12 locations. So you will hear talks about different data topics and spheres: data science, big data, data analytics, and data visualization. So stay tuned, and you will listen to many interesting things. So, and yeah, how we will do it? Next slide, please. Yeah, so first, please open YouTube, directly YouTube, not in communities platform. You can just click on the top of YouTube player. Please ask questions in YouTube chat to our speakers, so they will have time to answer your questions. And please participate in voting in YouTube chat. Yeah, speakers will ask questions. You will ask interesting questions, so to understand our audience. And yeah, please actively participate in discussions in YouTube chat. So thank you. Let's wait for our next speaker.
Hello, hello everyone, and welcome to Winter Data Meetup from Zen Community. Our speaker is Maksim Sapukhin, and he will tell us why business needs data and how data solutions can improve business based on his real life experience. Please don't forget to ask your questions in YouTube chat. Hi, Maxim. It's so nice to see you here. The floor is yours.
Hi, everybody. Yeah, it's exciting to be here. Thanks for letting me join and share some of my experience. Okay, so my topic is not very technical. I would say it's not technical at all. Rather, I would like to share some of the business expectations and business view on data-related projects. So I'm sharing based on my experience, because I've been for 15 years in manufacturing and retail. I was taking some C-level positions there, and then being business consultant. And actually, that's how I got into data field and BI field, because I felt that really business is missing some really important tools, and it's missing efficiency using all these Excel spreadsheets and stuff like that. So for 7 years I'm in BI related projects, and for 2 years I'm in PAM and really enjoying my current role. So again, I'll be talking more about projects that aim to bring value to end business users, those guys who are actually trying to do their jobs better, to achieve their KPIs, and usually they're using one of the BI tools in front end. And my goal is to highlight value which they are expecting, because like being like in developer position or engineer position now, I often kind of catch myself that being in different position, in managerial position, I would expect a little bit different things from dashboard or report that now being an engineer. So please use it when appropriate. I mean, not every project, not every business expects you to give some advices or bring some expertise in business field. So, but many businesses are open to it. So, back to data. Well, it's kind of a common thing now that data is essential part of business. You don't have to discuss it anymore. I've got few quotes with the help of ChatGPT on why data is important. So it's like new oil. It's the most valuable assets. It's foundation. It's like basically no one argues that business needs to use data to improve its efficiency, to compete better, and just to exist, basically. And what are some expectations like business has from data related projects, and we as engineers are focusing when we are delivering these projects? So let's start with our day-to-day priorities. We need to finish our tasks in time. We need to finish them within scope and within budget, with highest possible excellence. So as engineers, we tend to focus, and that's absolutely the right thing, on delivering technical side of the project. And we are assuming, and rightly assuming, that business is responsible for providing correct requirements and scope. So, but what are business priorities? Here I'm referring to latest Gartner survey on objectives of digital investments over the past couple of years. And we see clearly two groups here. First, about top line impact. So that is all about revenue, how we improve customer experience, which actually goes to revenue again. It's basically how we keep existing clients and existing revenue. How we introduce new products, that is how we bring new clients and again grow revenue. So business expects that digital initiatives, data-related project will help them to make better decisions to achieve these top-line impact goals. And second group is bottom-line impact. That is how business wants to improve its efficiency, like inner processes, operational excellence, employee productivity, cost efficiency, improve employer experience sometimes. So, and that is what business is really focused now, because when economy is balancing at the edge of recession, and not always business can do something for revenue, to grow revenue, then business usually focuses on bottom line impact, on increasing productivity and cost efficiency. So that is value business wants to see, not only on like C-level, but also like manager who uses some of our reports, production manager, marketing, sales. They want to improve their results in everyday life. So, but I guess it's also not a surprise that half of digital initiatives lacks leadership expectations. And there are two main reasons. So first one is that it takes too long to complete those initiatives. They taking much more time. And the second one is that it takes too long to realize value. And that is really important one, because again, objectives were to get some additional value from these projects, not implement some technologies, not implement some new tools, but to get additional value. And if business doesn't realize this value, that's a problem, because it won't invest money till it gets it right, till it will see how he can get value from it. So, and here I want to dive a little bit more deeper in business frameworks, not technical ones again, but I believe that might help us to understand how we can bring more value to business if we remember some of core business concepts. And one of the frameworks which is used very often, it's kind of old one, but still most of the companies are using it in one or another way, modified. So this is just a very basic example. It's balanced scorecard. So, and company using this structure to prioritize, clarify their strategic priorities. And again, on the financial perspective, because business, it's all about money. I mean, we can have all other talks, but if business doesn't bring money, it just stops its existing. So again, we have productivity strategy and revenue growth strategy, which are very well referring to what we've been to what we've seen in previous slide. That is bottom line impact, that is about our efficiency, and that's top line impact, that's about our revenue. So together they make a profit. We take revenue, we take our costs, and what is left is our simplified, it's our profit. So, and then we have customer perspective, where we have goals and initiatives, where we define what we have to achieve on customer perspective to achieve goals on financial perspective, like what kind of price we should give to our customer, what kind of quality we should give, what kind of availability, and all kind of things. They can be different for every business, but usually it has this structure. And where our projects are very often are like data related projects on internal perspective, that's where company processes are, what processes must be in place and how we should improve them to achieve goals on customer perspective. And then goes learning and growth perspective, again, what kind of human capital and other things that we need to have in place to support all other levels. So what is important here is to understand where our project, where we can map our project on this kind of structure. And I want to share very little simple example from one of the recent projects, and to illustrate why this is important to understand this structure and to place or map our project into it, and what can go wrong if we are not following some good framework in it. My example, it's like very simplified again process. It's about quality assurance process. So we've got some production lots, which is piece of production, let's say a pallet of manufactured goods, which takes some quality checks during manufacturing process. And if everything goes fine, it goes straight to warehouse. But if there are some possible issues, like at some point of process something might went wrong, then it goes to like quarantine. So it's put aside, and some investigation takes place, and if quality is confirmed, again it goes to warehouse. If some piece of production has some issues, it might be resorted and then packaged again and go to warehouse, or it can be totally scrapped if there's some major issues. So when we started working on this project, we assumed that we are here, that we have this quality assurance process, like on internal perspective, and it affects quality. We've got some initial requirements, some Excel reports, and business would say, okay, we need this and this kind of charts finally. And that was like more about quality, like what were the reasons for those lots to be put on quarantine, what kind of production lines we would make more issues, and all kinds of information related to like quality issues. So, and we would do some work, and we would prepare a data product having all this information, all this data, and some mock-up for dashboard or some prototype. But when we started discussing it with business, really what we came to was like they needed right away that right now their pain was availability. It was not about quality, because production lots which are on quarantine, they can't be delivered to the customer. They are produced, but they are put aside for sometimes for a long time to do these checks, to resort, to repack, and stuff like that. So they are not, they couldn't be delivered to customer, which of course decreased utilization of production lines. So actually it needed different set of information, of data. We needed to pull more data from SAP, and we really needed to rethink the whole concept of this project and rework some of it. Fortunately, it wasn't like a large part, and we delivered it in time. But what could be done to avoid it? What could be done better in this case? I will go to the framework, which business, first of all, might use or should use, I guess, in all this kind of projects. And it comes from Bernard Marr. He's a consultant also in data, and but he is like on business side, and this comes from business side of projects. So, and actually very straightforward, has 5 parts in it, starting with defining objectives and information needs, then collecting right data and information. That's where we actually starting working normally, because that's where engineering works start. And then analyzing data and gaining insights, presenting and communicating it. And finally, business is making evidence-based decisions or data-driven decisions. There are different ways to say it. So it's all about coming through this cycle to make better decisions, which help to achieve like business objectives, business strategy objectives. And business sees IT infrastructure and BI application here as enablers for this process. And this part is actually business responsibility. But the issue is that in many cases, especially if we are doing projects on the level of some units or departments, they're not really aware of how to approach these projects. These frameworks are not very widespread still in business, throughout the business. So really what we need, what we can improve here is to try to drive attention to this first box here, to this first, to the start of this process. Because if we are not answering these questions, everything else can go really wrong way, and we will be answering wrong questions and getting wrong data, and finally we will need to rework it, or business will not use it, will not see value because it wants something else to achieve its goals. So, and to clarify a little bit how we can approach it, it is about asking right questions, because asking right question is a way to get the right answer. So, and there are, again, same source, and there are like 2 types of questions. First, key performance questions, which are actually help us to define where our data, our process should aim, like what aim it has here. And these 2 questions here are illustrating it, like to what degree we can ask relating this project. To what degree are customers who receive our services are satisfied with quality? And then we would aim this box, this goal. And then we will need all information which will help us, to achieve this kind of quality. We can dig into the reasons, we can connect it to equipment, materials, and it's the total big set of data here. And on the other hand, we can ask to what extent quality assurance process affects availability. And then we need a totally different set of data. And we will build very simple report, like report which will be used by some manufacturing manager and quality assurance manager who would, come to his workplace in the morning and see, okay, I've got so many lots on quarantine. I can make sure today that these are passing all the needed investigations. These are getting resorted. These are getting repacked and send it to warehouse. And he's got all actions right here in one report, and it is totally different. So that is really small piece, and it seems very obvious, but it gets skipped many times, which causes rework and which might lead to loss of value for business after we finish this project. So to sum up, I guess, again, business needs data to make better decisions, not to look and play with some fancy dashboards or just to have all data possible. Every manager, every CEO has his goals, and usually those goals are coming to financial perspective. So if you can make sure that we don't miss this first step, if business didn't do its job, try to address these questions during discovery stage, during when we discussing like dashboard mockups or gathering some information from business. So I believe that might help us, and that will bring value, which that might increase value, which we are bringing to business. Okay, that's my little speech. So let's go to questions and answers.
Thank you, Maksim. That was very interesting presentation. And okay, so let us say a company wants to use data. And you told us that data can help to improve business, but can data improve any kind of business?
Well, I believe absolutely so. We can, I guess, take any example, and probably we will find one way or another to increase it. We can do it on efficiency side, because actually referring to my experience and the way I came to data, you can, with like existing tools, usually you can keep only few priorities very clear to yourself. But after you answer one questions, okay, we have decrease in sales, but why? You need to go, wait for another week to get answer, and then you don't need this answer anymore because something else has changed. So, and like modern technologies, they allow to keep in priority a lot of objectives and a lot of goals, and we always can find some way to improve.
And if we decided to improve our business using data solutions, how much data a company needs to start this improvement? Is it like a day or a year or?
How much historical data?
Right. When do I start? Let's say I have a startup, and when do I start to use my data to make improvement?
Right away, because it's not about data. Like it's again one of the issues that we first think, okay, we need this data, or we need this kind of dashboards to manage our business. It's more about what our goals are, what questions we want to answer. Like if we want to answer questions like how our customers are satisfied with our production, with our products as a startup, then we will need to get some data to answer this question. So if we will answer another question, like how we can improve efficiency, when we will need another data. So it starts with questions, not with the data.
Thank you. And if a company wants to use data to improve, do they need data IT department for it? How do you think?
Well, I think again, they need to like embrace idea how they want to use data. They need, for sure, they will need data engineer to let them, play with data, investigate data, but discover data. But first of all, it really should start with understanding what they want to achieve with this data, and then it will be more clear. Like, do they need engineer? Do they need BI developer? Do they need data scientist? Because it depends on what they want to achieve.
Well, thank you, Maksim. Thank you for your answers. I guess we don't have any more questions. Thank you, everyone, for watching. And see you at the next event of our conference. Thank you, Maksim.
Thanks a lot. Thank you.
I can't hear you. Mute.
Sorry. Yeah. Hello, everyone. It's still Winter Data Meetup, and our next speaker is Shiva Achari, who is a big data solution architect in EPAM, and he will talk about very interesting topic, data lakehouse. Let's learn more about this architecture. Please don't forget to ask your questions in YouTube chat. Shiva, floor is yours.
Thank you. Thank you, Alexander. Yeah. Hi. Good morning, everyone, or in different part of world if you are, or good afternoon or good evening. Welcome to this data lake architecture pattern. I will be the host. I will be talking about this architecture. Be as interactive as you can. If you have any questions, please post it in the chat. I'll be able to respond as I go, and I will be able to respond to you at the end of the presentation. So let's talk about data lake architecture pattern. So this is my introduction. Uh, so I have total 15 years of experience with a decade in data and analytics system. So I joined EPAM 4 months back. So I work as a data solution architect currently. As working with AWS as a data lab architect. And before that, I was working with Hotstar, which is acquired by Disney Plus as a data architect, technical architect in India. And I'm an author of a book, The Hadoop Essentials, which is by Pact Publication, which is based on Hadoop and ecosystem components. You can look at it. And I'm also author of blog post on Spark SQL based ETL pipeline on which is live on the AWS blog post. And I'm very active in LinkedIn. So if you guys are interested to connect, please feel free to reach out and I will be more than happy to connect with you guys. So let's look at the agenda for today. Today we are going to cover some the introduction part of data warehouse, data lake, where we will be covering introductions and the components which are involved in data lake. Data lake house will cover introductions and approaches of how to data lake architecture is designed. Data mesh. Data mesh will be purely introduction. We are not going to talk about the implementation part of it. We'll just introduce the topic and question and answers. The intention is to have the audience understand the difference. Each of this architecture are well suited for a specific use case. The intention or the outcome for this talk would be to help you understand this distinction, which architecture to use where. So if I ask anyone, like, let's start with the most important thing, uh, which is data growth and trends, which are the prime reason why we have different architecture that we are going to discuss, right? And in this slide, we have the infamous article by The Economist, which was 2017, which, and especially the quote, like, the world's most valuable resource is not oil, but data. This holds true. We know data is a strategic asset for every organization. Data has gone from being something that was cumbersome and expensive to store to becoming the lifeblood of many of the company's business model. Companies today are using data to drive decisions like when to offer new product offerings, how to introduce new revenue systems, and automate manual processes, how to earn customer trust. This is very, very important. Many use cases work around personalization to earn customer trust. All these decisions are fueled innovation and to drive your business forward. And it is the core part of its data. We hear from companies all the time that they are looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital business. Data is growing exponentially, like coming from a new source. It's increasingly diverse. and needs to be securely accessed and analyzed by a number of applications and people. Data is the core behind every business and every decision. So this is our first topic, which was the analytics. Traditionally, analytics used to it looked like this, like from OLTP system like ERP, CRM, LOB, all of this system data was pushed to a data warehouse, and it is visualized by the business and intelligence systems. Uh, some characteristic of data warehouse specifically are like data was completely only relational and structured. Uh, it can scale up to terabytes of and even max to petabytes, not beyond that. Either it would be not able to scale or it will be very expensive. Schema has to be defined prior to data load in data warehouse. This is a significant block in terms of adoption, and it takes a lot of time. It is ideal for operational and ad hoc reporting. It still is ideal for operational and ad hoc analytics. It is not like it has gone out. Data warehouse still, I would say, in most of the use cases are very good for ad hoc reporting or operational reporting analytics. Another important characteristic of data warehouse is it has a large initial capex, which means the company has to pay uh, or like upfront, like, and it is not often, most of the time, it is not proportional to the usage of how they're using the data warehouse systems, and they are expensive, uh, need to be taken care of. And why suddenly to go out from data warehouse? Some of the things that triggered over the past 5 to 7 years, a couple of key trends have got us to this point. So we have got various devices now, connected devices, apps, and systems now generate more data than ever before. Like as per statistical reports, data grows more than 10 times every 5 years. Like data platform migrations are not easy. Like data migrations are very difficult decision. It takes a lot of time and effort and money, and not easy to build and test. So it has to be designed for at least 10 to 15 years kind of state. And data growth and scale has to be supported by the data platform, and that is why there are different architecture that we are going to discuss today. With the improvements in the data analytics like machine learning and AI tools, and technologies have significantly improved, so we see more personas or user profile wants to access the data and derive insights from the data. Also, the requirement for data platform are more complex, so as platforms should be able to ingest a variety of data. When we talk about variety of data, you're not only talking about structured data, you're talking about semi-structured data or unstructured data like videos, audios, your chat information, emails, or various other things will come into categories of semi-structured or unstructured data. And we have a lot of sources where this data variety of tools are captured. Platform has to be flexible, scalable. Scalable is very important. As the we see the data growth is increasing, the platform has to be scaling as per the requirement, as per the organization growth or the data growth axis of it. Some system require near real time or real time access, right? So these are some of the characteristic or some of the requirement which for which like traditionally data warehouse were now designed to the variety of data set and scale, on the scale that we are talking about on exabyte scale, not on petabytes, but many organizations are having exabytes amount of data collectively, and they want to do analytics on those data set. Due to this limitations, data lake architecture was designed. right? So we'll talk about that data lake architecture. So I just want to understand the audience better. So I have a question, and you will be able to see in your the platform the question and the answers. Right? So please answer this from my understanding. So what is your current role? Yeah, Alexander, you
Looks like I have data engineers, and we have a little of architects, 10% of architects and team leaders.
okay? So majority are data engineers and
Mhm.
architect in that category. Okay, good to know. So I will use this information to align myself and emphasize on some other topics which that role will be more interested in. Okay, okay. So let's talk about data lake. Like, what is the data lake as a concept? Like, data lake uh, is a centralized repository of data that allows you to store all of your data. It's the underlying word is all of your structured or unstructured data, no matter the scale. At any scale you can store your data as is without having to first structure the data and run different type of analytics, like from dashboards or visualization to big data processing, real-time analytics, and machine learning to guide better decisions. So some characteristic of data lake are like you are collecting, ingest and store to store structured like a variety of data that we discussed, like at any scale, and more importantly, it should be stored at low cost. Data stored should be searchable and discoverable in data catalog, which holds metadata about the data, and this data catalog acts as an interface for discovering and accessing the data. We will look at an example of that. Another characteristic is to decouple storage and compute to achieve independence in storage, like and compute to enable different analytic tools to integrate without data movement. So data need should not be moving around this platform. The core piece, the data underlying data should be available in data lake, and different analytical tools should be able to integrate and access that data rather than data movement or loading the data into the system. We will avoid or limit those kind of movement. Storage should be durable, available. It should be scalable up to or beyond I would say exabyte scale. uh, you it is it should be supported to run different type of analytics. It should be integrable to different set of tools, from like data warehouse, machine learning, AI, predictive analytics as well, are very common or very requirement for organization. The architecture has to be flexible and integrable to other analytical system. These are some of the characteristic of a data lake. So there is no formal definition to a data lake for it's a approach or it's an architecture, and these are the characteristic that guides us to build a data lake. So when we talk about data lake, all these attributes should come into picture, not one or two. It is all of them needs to be there. Then we should call that as a data lake. So let's look at, I just wanted to, this diagram would depict components in data lake. I'm taking AWS as an example, but you can, it is applicable for open source and other clouds as well, the similar architecture. So at the core of the data stored is central storage, which is S3. If you're familiar with AWS, we have S3. In open source Hadoop, we have HDFS as the store. The data ingestion is the first layer which will read the data from sources and store the data into the data lake. So this is the ingestion layer. So some of the services within AWS I've depicted, like you have Kinesis data firehose to store the batch data. You have Kinesis data streams, which can ingest the streaming data or near real-time system. We have database migration service to load the data from OLTP system or RDBMS system. Uh, you have storage gateway to read the data from a specific gateway, like specific drive or specific hardware. A direct connect, like where you connect to a different cloud or a data center accordingly. You have Snowball as well, as in data ingestion tool. This is the first component. Once the data is loaded into, uh, iteratively the data should be cataloged, it should be searchable, and it should be available in a catalog. For example, Elasticsearch or OpenSearch, I would say. OpenSearch is a tool which is open source, and it is a new version of the new fork of the Elasticsearch, which are open source now, which will make the data within your data lake searchable if you integrate those. There's a Glue catalog, which is comparable to your open source if you're familiar with Hadoop, which is Hive Metastore, but it is or like which will you can consider that it holds the metadata of all your data lakes or data stores, as well as the access, who has access to what, to that, like granular level on that. Glue as another piece of ETL, that is a different topic, but this we are considering calling out data catalog service within AWS for integrating. As we discussed, this catalog is extremely important, and it is an interface that will be used for different tools or in this layer itself, which will integrate via the data catalog. So this becomes a central piece or very core piece in the data lake architecture. Once we have done this, the data management and security is also very, very important in any data world. Like you're talking about, uh, like storing the data in encrypted form. For security and audit purpose, you will want to monitor your data set, and so manage and security services needs to be enabled on this data lake for operational perspective. Then comes, this is the most interesting, or most of the users would be familiar with this analytical serving tool, like which is, there are different type of analytics tool which I'm trying to depict here. Like it's not only one, and data lake or the data which is there in S3 are integrable to different set of processing or analytic serving layer, like Athena, if you're familiar, Presto like, which can run SQL query on the data which is there on S3. EMR is your Apache, Apache Hadoop version itself. You have Glue for ETL processing as well, QuickSight for visualization layer, Kinesis for near real-time processing, Redshift is the data warehouse, DynamoDB is a key value store within AWS, Elasticsearch are open source service, Neptune is the GraphDB, RDS is the OLTP. So if you look at it, in the data lake is set up, or S3 is uh, structured in a way where it is integrable, and the interface that is between is the data catalog and the access permission management as well. So rather than moving the data into the system, it is accessing the system, uh, which is a drastically different approach, and which saves a lot of time and effort uh, of different teams. Like you will have different team need access to different kind of analytical tool, rather than working on data movement or loading the data into the system. If you are able to integrate and access the data, verify whether this data model is the right fit, so it gives you a lot more option in terms of ad hoc analytics or processing, and make sure that you are whatever analytics or idea that you have in mind are working correctly as per expectation. Then for interfacing access and the user interfaces that we call as, you can have access to this data securely using gateways. You can build APIs to access those data. Cognito can be user-based interface from mobile for mobile devices or user authentication. AppSync can also help in enabling access and like sending the data to syncing the data into different multiple devices and all of those stuff. So as you can see, you as a data lake approach, it's not one service or one part. It is a combination of all of these pieces that come in shape to build have this data lake architecture to be built. So as an architecture, when we call as a platform, all of this component should gel together as one. Okay. So yeah, this is another question which would like to say. So if you have an understanding of a data lake, or you have worked on it, what does data lake mean to you? Like data store, is it supporting self-service BI analytics, or a staging layer for other platform, or single source for your analytical and operational workload, or a data science sandbox, or is it a replacement for data warehouse? Just going through one question from James Bond. So I mentioned like many of the AWS service can be used for data lake. Can I implement data lake properly without learning deeply all of them? Yes, you need to this services you need to understand like different personas will be managing different layer. Like it's not one team or one system who will handle everything. So yes, there will be a data platform team who will govern this, but there can be another different team who will be managing this analytical services integration, or access management can be different, security could be different depending on organization. Yeah, if you are in an organization where you do not have, or you can have that skill set, and you will have offload to that team who can manage that specific thing. So technically I would say it is a combination of multiple roles of the team. It is uh, easier, like it is like you need a team to build this data lake as well. So wait for 5 to 10 seconds till you answer.
Yeah, so we will collect answers a bit later. So
Got
let's
it.
move on.
Let's move on. The second architecture that we have today that we are going to discuss is lakehouse, data lakehouse architecture. So we looked at two architecture, like data warehouse. We have a fair understanding because it has been for a longer time. We have seen data lake. Both have their advantages and disadvantages. Because data lake also has like it requires, it's a different architectural principles, guidelines, technological skills which are required, which is different than data warehouse. So there is a learning curve, and how it manages. It works on the actual raw data set, right? So where uh, and you are working on different layers to get the best of both of these. Like like since I'm already mentioned, like data warehouse is also is significant now as well in this part of world. Like we can see for reporting and other access, data warehouse is a very good choice. To get the best of both of this, the lakehouse approach or architecture have come into picture. Like some of the trends driving the architecture are enlisted. The reason, like the new data sources, we talked about the similar trends in data lake as well. It's not very different. Like empowering personas, use the best fit analytic, growth in open data formats. Now you see a lot of different data formats, like Parquet, uh, ORC, which can be used for structured, but it takes it to a different level itself, where you can analyze the data rather than scanning all of those record. You can just scan a specific columns that you're using, which is very common. And it is like a columnar data format, and which is widely used in this part of data lake world, like streaming data analysis without loading it first, single source of truth, unify analytics, a unified security compliance. Like these are some of the trends, and the reason why it is a significant amount of time, effort, and money goes in re-architecting or and data ingested to and from different platform. Uh, Hence, lake house architecture makes a lot of sense. We're gonna see of how we are talking about why we are saying so. Why am I saying so? So benefits of lake house approach, like we talk about, we like we are looking at a scale of using the data warehouse and data lake in tandem, like along with side by side, where it should extend from terabytes to exabyte scale with low cost. Security is very important. We should empower the personas. We should be loading any type of data and analysis. We should The critical word also is democratize ML with SQL, or they would not need to require ETL or some other tools. So different personas has a different requirement of the tools. Like some of the business analysts would be familiar, like very competent with SQL. Some of them will be uh, competent with AI services. Some of them will be needed like a key value store kind of requirement. So different personas, different uh, integration requirement. So here's my honest approach to depict how lake house integrates the high level in a high level component. The key point is to not transfer the data. uh, and if there would be some data transfer required, but we would want to minimize that data transfer to and fro from data warehouse or data lake. As you see in the picture, there is already a data lake where you can keep the data. For example, we have seen that this architecture or this data can scale, and you are most of the time you're paying for as you're using. Like it's If you have that kind of data and you want to store that and analyze that now or later, you can store that in data like it is very cheap. And then you have a data catalog, and then data warehouse on top of it. So data warehouse, uh, if we look at in a way where data warehouse also integrated with data lake, and data warehouse acts as an interface or an layer where the BI and analytics apps are connected, so that your visual layer or analytics layer can be run via SQL. You can have ML integration on data warehouse rather also, as well as in data lake, like depending on if and when we say ML integration on data warehouse, we're talking about ML integration which can be used via SQL queries. Uh, and also uh, it can be there are tools which can be also federating queries to operational database, querying live data. For example, you can have a data warehouse which can query the data from an RDBMS tool, and in a single query you are able to query the data which is there in data warehouse, as well as in data lake, in the operational DB in a single query. And that's how powerful this tool, this architecture can coexist. Like this is a powerful tool. The main reason is data lake, although it's everything fancy, everything goes on very well, the integration piece to BI analytics uh, needs to improve. And one of the best ways, utilize the tool which is already tested product, which is data warehouse. So Another way to look at is how do we approach in uh, conceptually, how do we look at what is a data lake approach, like what are the key benefits as well. So assume we want to analyze structured and unstructured data with minimal movement. Like we have a data warehouse that stores business data and a data lake that stores all the data. We want to avoid or limit movement, we drastically reduce data swarms. Like data swarms are each individual team having their own silos of tables or structure, which are very common in a large organization. And over a period of time, there will be many such data warehouse tool licenses, which uh, uh, which they are baffled with in terms of why they needed. Like it can be overly simplified. So data swarms is a realistic problem in many big organizations where they have each independent team have their own data or data created in the data warehouse, so they would have licenses and other costs. And most of the time, as I mentioned, the license costs are not directly proportional. It's not utilizing to that level as it used to be. It can utilize say max 50 to 60%, not beyond that. So we would for doing this, some of the things that we want to look at is we there can be other data sets in or like each in different team, like the business data, marketing team, sales team, who can have their own data warehouse. Like and how do we solve this problem of lake house? Like how do we want to do that? We can't get rid of this. The problem that we have is the data needs to move from one data warehouse to another data warehouse system. Like of marketing data would need to have data from sales and business data accordingly. The change that we want to do or enable in this data warehouse tool is to have no data copy, to have data sharing within or across this data warehouse, which means you let them have an independent data. The data would not be shared, and when we do this, we are no longer giving them a mandate like they need to copy this data and then duplicate the data, and each of this layer have their own version. They can easily access the data which is from marketing or sales or business data, whatever it is, without copying that data. So there's a single source of truth in this, and it makes a lot of difference in how that reducing data swarms. So capturing real-time insights via federated queries to transaction, like you will also ideally want to enable this data warehouse tool to integrate or access the operational analytics or real-time analytics system, the OLTP system, I mean to say, in a real-time fashion where they can live query on those data set. Also, if possible, it can be integrated to the third-party data, so external data set or platform that you may be organization may be using. Rather than moving the data in and out, you can either store that into a data lake, and if you cannot store that into a data lake, then access to from the data warehouse tool to this part is highly recommended. If you ask me practically, do we have a data warehouse which can do that? Yes, AWS or as a tool which is Amazon Redshift, which can do all of this piece, right from integrating to data lake to having a federated query to the OLTP system or RDBMS, and integration to ML as well as to external data source platform as well. Not all of them, but some of them. But it is a start to the journey or the process where data warehouse can become as an interface for all of your purposes. There is Snowflake as well, which has a very good integration to data lake and other um, like uh, like some other features. Uh, so you can very well have a look and see if there are tools which you will prefer, which has this benefit for lakehouse approach. Hope this was clear. Due to the time, I would want to go a little further for the next. If there's any query, I'm more than happy to answer later after the end of the presentation. Okay, so the next architecture that I we wanted to discuss is popularly known as data mesh, right? It's not a architecture per se. It is an approach to building how we look at approaches of how to what all components are involved in data mesh, what is a data mesh, like like a data mesh is a socio-technical approach, which means it will align to as your current organization are. Each team will be able to have their own data data products, like data factory that we call as. We'll come to that. So we are going align with having the same organization feature, like how you are structured or hierarchy in your data, to build a decentralized data architecture by leveraging a domain oriented, it is to be self-serve design in complex and in large, and it is very useful for large environment within or across organization in different multiple different countries as well. Like you have now a lot of regulations, so uh, you need to have such an architecture which can span across different geographies, and with compliance and all, it becomes more difficult. So data mesh is one of the approach to build such layers or data architecture layers. So conceptually, it is based on four core principles: domain ownership, like which are operational and analytical data, which involves domain bounded context design approach, like domain bound. So you are having a domain of and all the related data will be stored in that specific domain, and that's a kind of approach, and this is called as domain ownership. So there has to be a domain team who will manage these domains. Consider domain as a set of all the data set required for a specific entity, right? uh, like for a specific for a specific facts, or and some other dimensions related to that fact. Like data as a product, the second layer is data as a product. Data as a product acts as an interface which requires data, like which acts as a which is managed by the domain team itself, and domain team will recognize what data needs to be accessed to outside of or to different domains, like uh, which means they are making that data available for analysis or query. Okay, the third layer is self-serve data platform, which are domain agnostic, like, and are managed by data platform. Self-serve data platform means the team are independent, or like, rather than relying analytical team relying on uh, for example, a table to be added or a column to be added. If the data is ingested, we have seen in data warehouse, like a single like, even if the data is ingested, it has to be like you need to add the column, and then provide access and all of those feature. In self-serve, if the data is ingested, for example, you are loading the data from a source which is giving more columns now, like earlier it used to give 50 columns, now there are 55. uh, it is if it is We just need to push it into catalog, and once the data is in the catalog, the team who have and provide access, then the team would be able to read the data without any other engineering steps, like they are able to access those data set accordingly. So which is called a self-serve data platform. The fourth and one of the most important layer is federated uh, computational governance, and it is focusing on to manage a governance managed by, so usually data stewards or security managers or data security managers. This is this principle would focus on like tightening the security, the data product that has been accessed, who has access to what, in what granular level. uh, just for example, there can be a data product which has PII columns, and not everyone in the organization would need access. So even though some would require access, so you have to publish that data set. Rather than duplicating, you can have a mechanism of data masking or redaction, right? And then you will be able to see a query, but you will not be able to actually see the data, what is the value. And it is useful in many of the compliance level masking you can set up. So this is how it is very useful. So data uh, mesh federates data ownership among data or domain data owners, which are held accountable for providing the data as a product, while also facilitating communications between distributed and data across different locations. Like this is an understanding of data mesh. So we talked about some of the concepts, right? Like data domain and data product. So what do that mean? Because it is very important to understand. Uh, let's look at data domain. A data domain is a collection of, you can say, a team or a people which typically are organized around a common business purpose. Like you will have sales or marketing team or a specific team, or who will be holding or managing those specific data set. Like there will be a team who will be managing that domain. And from the data management perspective, these people create and serve out data assets on full like oriented on fulfilling certain business need, I would say, use cases, which are independently from other domain. Like some feature that we want to have in data domain is data asset to be should be shared, like must be to be shared or must be accessible, available, and meet the quality criteria defined. Data assets are evolved based on user feedbacks. Like domains are commonly organized around and aligned with data semantics, usage scenarios, and business capabilities. So when we talk about data products are the interfaces of the data output of some teams, like our system to analyze the data within the organizations, or uh, most often it will not be external but within the organization if we limit to that. Data product is an independently provisionable or deployable component. It is focused on storing, processing, and serving as data. So each product data should be implemented, evolved, or maintained by uh, actually by one domain team only. Uh, so if I have to talk about data product, like a data product is a data asset which is made available for broader consumption. Like it is supposed to be consumed, and it contains defined and monitored delivery contracts, which means uh, so even though the data is available, who has access to what, like whether it needs redaction, masking, or like if it is non-PII that can be sent, that kind of contract needs to be adhered, needs to be maintained in the federated layer as well. uh, Aligned to domain business function and goals, it is optimized for readability, and it adheres to organization governance policy and standard. So as we talked about, this all layer can be like managed independently, which means uh, if I look at the architecture, if I take a stab at explaining this architecture, that architecture will depict the four principles that we talked about: domain ownership, data as a product, self-serve data platform, and federated computational governance. These are the four principles that we talked about for the data mesh. Like within each principle there are policies or responsibilities that we'll look at. Like the ownership comprises of operational data, right? Data products on analytics, and data contracts for interfacing with other domains. So the other domain will be able to use this data contract, and then whatever data is published can be accessed by another domain. uh, so if we look at it, one domain can be in one geography, another domain can be in different geography. So the geography contracts and everything needs to be uh, like contracted or managed as a policy. The second is data as a product approach that we discussed. So when we talk about a domain, the domain product will be saying, okay, what all data are can be shared, and they will own that, and that is what we are going to publish. The third principle is the self-serve platform, which is at the bottom, where you say uh, it's a platform responsibility to manage security and query engines, data catalogs, access management, monitoring, and policy automation are very very important for in this layer. Federated governance comprises of interoperability policy, documentation policy, like security, privacy, compliance, related contracts and policies. So if we look at it, all of these principles or layer can be loosely coupled, or has to be loosely coupled, I would say, which means each domain will be can be a separate uh, platform which is independent from the federated governance, can be separate from the self-serve data platform, can be and then it is enabling for this. So then you independently the team would work on, and data product acts as an interface for domain, and the contracts governance will be managed, and the platform data platform will be able to read all of this, who has access to what as a consumer, and according to that the data access will be there, or the data will be able to share across geographies. Although I mentioned it very in a simple manner, it could be a bit like challenging, because to understand so to design this is the approach, this is the first step. uh, this is, I would say, the zeroth step, not even the first step. First, to understand this, how this layer would be developed or will own what within the organization, that is the first step. And then building on top of it independently, each domain would work on it, governance, security, and all of this will fit in very well. And implementation of this could be called as a data mesh architecture. It is growing very popular among a bigger, larger organization who has many companies widespread across organization, and they want to understand details or understanding about different layers of it. So that is a data mesh architecture. So time for questions. This is a question which I would like to understand the interest from the user. Which data architecture would you like to know more about? Like, is it the talk about the data lake or data lake house or data mesh, or if there is any other architecture which we did not cover, please specify.
Yeah, and looks like we already have results. So like half of our audience interested in data lake house, 50%, 26% data mesh, and 19% data lake.
Okay, okay. So yeah, so just to like, it's not a surprise. Like data mesh and data lake house has an inbuilt data lake. So the understanding of data lake is very very important. But data lake house, that is the beauty of this different architecture with respect to data. We are talking about independently. It When we talk about data domain and data mesh, like the data domain can be a data lake itself, or it can be a data warehouse system, but the interface need not it should not be different, because you are like publishing a data in a form that can be used across. That is why all of these pieces work in over here. And I think this was yeah, this is what I had in my mind to discuss today. Thank you so far for listening to me. Hope you got some of the details or understanding. I'm open for questions and answers now.
Yeah, so we have also questions. Uh, yeah, which of these approaches is more expensive to develop?
Uh, Cost is I would say expensive. Data mesh involves a lot of components. Like it is an we are talking about different components in data lake. We talk about one layer or architecture which has principles which are integrated across. Data mesh can be in different cloud or different layer depending on, as we talked about, like it's for bigger organization, and if they have a need, uh, assume that an organization has 20 or 50 different subsidiaries. The challenge would be all of this organization, different organization or acquired subsidiaries can have data in different formats, different shapes. So you're trying to unify that. It would be surely expensive to build and manage those, but it is the absolute need. So the question would be, what is the organization gaining out of that? What is it is driving a business, or it is improving a customers? You are getting business out of this data. You're not doing it just for fun. So depending on how much you are driving the business, your cost and expense could be managed. But yet, just to answer in short, data mesh would be more expensive. Data lake house could also be expensive depending on the pricing or the model that it could be. But data mesh, I would say it would be surpassing all of those.
Yeah. Also, in your diagrams, you mentioned many AWS resources, many AWS services. Yeah. Does it mean that to develop this architecture properly, I need to learn all of them, and or maybe, for example, yeah, maybe or for example, there are ready-to-use solutions maybe on marketplace.
Yeah, so data lake would be very, very specific. So you can't pick a tool. It's a combination of multiple such tools. Like we have a data catalog. There can be a solution separately for that. You are talking about data security. Either you can use the cloud that provides that service, or you can build it on its own. So most often you it's a combination of multiple platform or tools. It's not only one tool that will give you a data lake. Not just by dumping the data in S3, it's not a data lake. You're just storing the data. It's just one part of the problem. The compute or the analytics integration is another way. Then the access and management. So each of these are different layer. uh, as each there can be different team in within company or org who can manage those. So, and one user or one person who would want to who can manage all of those could be a challenging thing, but it is not impossible. It is possible, but it will be more of a responsibility, because your access pattern or the platform, the idea is you are trying to integrate or ingest various set of tools, and you will need to work on ETL processing and all of those. Having more responsibility on other layers could be more challenging. So you need not be, you can be an analytical expert who are using the data as a data platform. You can store the data, make access management, making sure the self-service platform is done, and then your job is done. You're democratizing your data, which means you are not taking the responsibility as a data platform. You're giving the responsibility to analytic thing, like you have access, you execute the query, you analyze that data.
Mhm. Yeah, and also we have a question from Andrei. Which AWS tool is best for establishing data governance process in data lakehouse and or data mesh?
Yeah, so AWS specifically in for lakehouse and mesh, AWS Lake Formation is one service which is catered for building data mesh and data lake kind of architecture. The Lake Formation is focused on these the accessing federation and all of this layer, which is a core purpose for building data mesh, as we talked about. So along with the data integration, so in AWS you can say data catalog, along with data catalog, glue data catalog and lake formation, the integration and how do you channelize those, so you can manage that access permission to a granular level, not only the database level. You can have till table level, uh, column level. You can even have row level access management in lake formation, which is what we want to build.
Yeah, thank you very much, Shiva, for your presentation. Looks like we have more questions. Yeah, please connect. Try to contact Shiva directly, I think.
Yeah,
Yeah.
as I mentioned my LinkedIn ID. The intention is to, uh, if uh, if you have any queries, I'm very active in this social media in LinkedIn, so you can reach out to me in case I can help you out in any way.
Yeah, thank you, Shiva. Yeah, so we have a short break, 4 minutes before next speaker, Pavel Goncharenko, who will tell us about data analytics world.
Thank you.
Yeah.
Thanks a lot for
Stay
joining.
tuned. Yep.
Stay tuned.
Hi, everyone. It is Winter Data Meetup from Zen Community. Our speaker is Pavel Goncharenko, and he will tell about data analytics sphere and how to grow as data analytics. We are waiting for your comments in YouTube chat, and don't hesitate to ask questions. Pavel, it is nice to see you. The floor is yours.
Hi, Volga. Thank you a lot.
Hi.
How are you?
I'm great, thanks.
Me too. So let's start. Data analytic engineering, guys. This is the topic for today's discussion. I believe after this short meeting, you will be you will have complete understanding what is data analytics engineering, what should you do to become the data analytics engineer, how it differs from data software engineering, for example, or data science or BA analysis. So today I will cover all these questions. So my name is Pavel. Let's start. Why it is popular? Yeah, why I am a data analytics engineer? What technologies do I use at my own work here? And probably the most interesting question, what tools, what technologies should you learn if you desire to become the part of data analytics engineer? And basically, let's start from the very beginning. What is data analytics engineering? From this naming is completely pretty simple. Yeah, data analytics engineering is a data analytics plus data engineering. Yeah, that's clear. But besides that, it's also have data integration and data visualization inside. So at epam.com, you can find this short description of what is data analytics engineering. In two words, just for your understanding, in two words, data analytics engineering is, I will call it the process. It could be the technology or tools, etc. The process, starting from collecting data through transforming, cleansing, aggregating, etc., and finishing the visualization of the data. So the process is complex. And it is a rare case when one single person is able to complete every stages of this process. That's why we can divide at least this data analytics engineering area by two, but it commonly used to three areas. So it is a data integration and data analytics and visualization parts. I will try to cover both of them, so we'll see what it will be. Please don't judge me about this picture. This is how I reflect the data analytics engineering with business intelligence analysis, data science, machine learning engineer, and data software engineer. This picture doesn't reflect the relationships between, let's say, data science and machine learning engineering, because of course it is kind of the part everyone knows. Yeah, but how it differs, you can see there is no strict border and could not be strict border between data analytics engineering and all of other data areas. Why? That's simple. Business intelligence analyst is able to do some work as data analytic engineer. Pretty simple dashboard creation, why not? SQL simple scripts, why not? The same for data software engineers. ETL processes, even using the same Python and PySpark, why not? Either data software engineer or data analytics engineer is able to implement the same task. But in general, the scope of work is different, the stack of technology is different, and the process is different. Probably later, if I have time, I will provide more clarity between this. But currently it is simple. Yeah? Data analytics engineering focusing on collecting data, storing data, of course, and in some technology. Yeah, right now we had a conversation where you definitely had a good understanding what is data lake, what is data mesh, what is lake house, and these terms are completely related to data analytics engineering world. So why it is popular? Yeah, regarding importance of data, today you heard a lot of information, and I believe you will hear a lot of information more. Data is extremely important. He who controls information controls the world. Yeah, so in nowadays data became something valuable and something important. That's why so many data related areas were created, appeared, and data analytics engineering is the area which revealed itself in many different areas, in all areas I would say. Yeah, data collection, that's ETL. Data storing, that's data warehouses, data lake, blah blah blah. Data visualization, that's visualization. So here we have four main, let's call it them blocks, yeah, of this data analytics engineering. So moving to the most important part probably, yeah, how to become the data analytics engineering and what to learn. At the first place here I placed SQL, SQL or whatever you call it, because it is the core language of data analytics engineer. SQL lived and will live forever, I believe. We can use SQL in every area of this data analytic engineering cycle. In the ETL, definitely. In data warehousing, definitely. In visualization, why not? Yeah. So even different areas like data software engineers also can use SQL even in complex ETL jobs using, let's say, Spark SQL. So SQL is a must. I do not mean that you should learn just basic principle of SQL. No, you have to be able to distinguish one SQL syntax from other. We have many different tools and technologies which have something in common, but every tool, every technology introduce something interesting. New clauses, new functions, new operators, etc. And that's interesting to understand the difference between them. Second place, Excel. This guy who created Excel, I believe, brought to world the most valuable software from my point of view. Excel is a great tool. You can do using Excel, if you know Excel well, you can do a lot of work. And I'm talking just about the basic functionality, not about the macros, etc. Yeah, I use a lot Excel in my daily routine for automatization, etc. So just to create bunch of the SQL script, Excel could be useful. You can create visualization. You can create ETL processes using Excel. Just no, of course, that's not a production like. There is no production organization which uses Excel only for data storage, for ETL processes, for data visualization. Of course not. But for basic understanding, for small POCs, just for automatization, that's a great tool. Postgre. What is Postgre? Postgre is a database. Yeah, in two words. But not only. Postgre is open source, and on Postgre there are many data warehouses created. Even in clouds, in AWS, we can we can name, let's say, Redshift is a data warehouse. It is a great data warehouse, but Postgre underneath, and etc. So many tools have a common syntax. Postgres is definitely good tool to start with, but of course there are SQL Server, Oracle, and I'm talking just about the relational databases. There are not relational databases, no SQL, yeah, which also should be taken into consideration, but Postgre is a must. Python. Python is the must-have skill also for data analytics engineering, because ETL actually you can get rid of the Python. Yeah, there are data analytics engineering who don't know Python, probably, but Python is a great programming language for automatization. Also, due to PySpark, it is Spark on Python, there is an ability to create ETL processes. Using, let's say, Jupyter Notebook, you can visualize and create this pipeline easily and present this data to the customer, etc. Of course, storytelling to create the nice looking dashboards, to understand why do you create this dashboard, why do you create reports, to uh, actually there is no such so many information in the bar chart. If you just have data or information and you presented this information, probably it won't help. But if you create this story using this graph, if you have, for instance, some insight using this graph, if you have some spike or something like that, and you pay attention to that, this is available. If you have like trend, this is also available. So storytelling is a must for visualization part. Cloud. Nowadays, cloud is the must. Many organizations move their on-premises technologies to cloud. And we have three major clouds, yeah, AWS, Azure, and GCP. Of course, besides that, there are many more, but major three. And definitely one of them should be learned. At the previous conversation, AWS was presented and many services were revealed. So these 6 tools which I highlighted, not tools, technologies which I highlighted for learning. Of course, it's not the complete list. To become a data integrator specialist or data analytics engineer, you have to have good understanding what and how to create ETLs, how to create data warehouses, data lakes, etc. What are the different models? These several points are must for start. Yeah, Kimball Inman. It's not probably so much, but every interview you will have a question. Yeah, what is the Kimball approach? What is an Inman approach? Why? What should you choose? What are drawbacks and benefits from each other? And it is definitely good good understanding just for a starter. Of course, after that, they were invented many years ago, yeah, and after that many new approaches appeared, let's say data vault or different types of architecture, but these are for starter. Of course, what is data warehouse in general? Concepts, methodologies, and data models are there. And regarding data lake, data mesh, lake house, right now you had a great video, great presentation. So I believe instead of this link, you can just revisit this video and you will get the good understanding what is the ETL. What is ETL? ETL stands from extract, transform, load. Under ETL, we have also mentioned ELT when it just swap two letters, yeah, extract, load, and transform, etc. What are the difference? What should you use, etc. That's also you have to good understanding to that. If you're talking about EPAM provides a lot of interesting mentoring program and courses. And actually, passing these courses, you will get the great understanding what is data analytics engineering, yeah, and what should you know to become a data analytics engineering. These courses are pretty useful, and I believe many of data analytics engineers passed several of them. We have here either ETL specific courses, data warehouse specific, and visualization specific. How to become data analytics engineering? As I said, we have two major groups, data integration and data visualization people. Data integration are working on ETL processes mostly and data warehouses. When I say data warehouse, I do not mean just data warehouse only currently. Yeah, I mean in data lakes and data lake houses, etc. All different data storage and architecture. Data warehouse is a pretty old term and it's kind of simple to describe that. So these guys, data integration engineers, are working to create the data centric solution which should be used by visualization team. Data analytics and visualization engineer creates dashboard. It is his the primary role, but how to create it? He definitely should be able to create data mart on this data warehouse to combine necessary data, or data mart also should be created or could be created by data integration. So they also have something in common, this data warehouse. If we have, let's say, middle data integration engineer, how it differs from senior data integration engineer? What should he or she learn to become a senior? Besides so important skills like soft skills and industry knowledge, here I enlisted several technical areas which should be also promoted from intermediate to advanced level, like data integration concepts, and of course clouds. Yeah, so to become a senior, you have to be able to create pipelines, ETLs, or etc. in the clouds. Or at least if you're a data visualization specialist, you have to be able to use cloud data warehouses. You have to understand how to connect them, what is the difference, how do they work, how do they differ from, let's say, if you're talking about cloud data warehouse, from on-premises data warehouse regarding the performance, etc. issues regarding the security. Databases, of course, there is not a good senior who knows only, let's say, Oracle, and that's all. Or if we are talking about a SQL Server, yeah, several different databases should be taken into account, and etc. Yeah, regarding data modeling and architecture, that's the huge part which should be covered mostly by data engineering, data integration engineering, sorry, but also data analytics and visualization engineers. Different approaches, different schemas, why and when you should choose, let's say, data vault or data anchor. Why should you choose just Kimball or Inman? Yeah, so there is no single task which clearly have answer. You should choose this model. No, but you definitely have to understand why. What questions to ask, what answer you expect to see to choose the desired model here. ETL tools. If you're talking about data integrator, again, ETL tools is the must. A good senior data integrator should be able to create ETL pipelines using several tools. At least if you're talking about just hard-coded Python, as I said, yeah, probably it's a good. But there are many no-code tools like Informatica, Talent, SSIS are different. So you just click mouse, create these blocks, arrows between them, and you create this pipeline. It is sometimes it's not easy to avoid coding, but sometimes it is. So ETL tools are must. And here, as you can see, there is nothing about data visualization, yeah, part, no tools, no technologies, because data integration probably has the final step of creating data warehouse here. So what technologies should we use? As I said, data analytics engineer has three different areas. It is ETL, it is data warehouse, and it is visualization here. Yeah, and everything of this should be related both to cloud and on premises. So cloud, if you want to start learning and you don't know what to do, cloud, definitely. AWS, Azure, GCP, actually there is no such kind of priority between these cloud providers. They solve different areas, but either AWS, Azure, or GCP provide everything for data analytics engineering. ETL tools, every provide one. Data storage, provide. Visualization, provide. So every of these three major company provide everything for the whole cycle of data analytics engineering. If you're talking about ETLs, of course, we are talking about integration platforms and different technologies. If you're talking about data warehouses, again, under data warehouse, I mean the whole data storage platform and visualization. So if you want to become data analytics engineer, first you have to understand what is closer to you, data integration or data analytics and visualization. And based on that, you have to be able to understand what is your focus in this case. If data integration is your choice, so starting from the very beginning, ETLs, data warehouses, etc. By the way, many of data integration in past were just usual database developers. Let's say Oracle developer or SQL Server developer. This guy who works at some business site in OLTP usually systems and after that decides, come on, I want growth. I want something more. And BI or data analytics engineering is a great area for growth. And we have plenty of can I call them ex database developers who grow from these technologies. I can call this legacy, but probably I will be banned, yeah, if I call legacy like Oracle legacy or SQL Server legacy. But that's kind of true, yeah. There is almost no pure Oracle development, Postgre development, SQL Server development in the data integration area. We use these databases as the sources, preliminary. We use them as the sources. After that, we create ETL processes on top of these sources and create these different transformation, cleaning, etc. And finally, we gather data from the different amount of sources into one place. Usually, this one place is a data warehouse, and data warehouse sometimes it could be Oracle, yeah. Sometimes it could be SQL Server, but nowadays, as the data amount constantly growing, so probably it is better idea to choose different model. Or if you are like to see the result immediately, right now, when you create something, you want to see the result. Data analytics and visualization area is yours definitely because you created the dashboard and immediately you understand how it looks like, what information it presents, and etc. If you are talking about data integration, you create pipeline. Yeah, you move data from one point to another. But what is the result? Yeah, what is the value to the customer? It's hidden. There is no visible results when we are talking about data integration. And your product could be used by data analytics and visualization to create dashboards. That's how it works. To become the data analytics engineer, you have to choose what is closer to you and work in this direction and uh, deep dive into one of these two areas. And the most probably complex part is the tools and technologies. Data analytics engineering is popular because there are a lot of different tools. Probably they do the same. Let's say ETL. Come on, you have to connect to data source, transfer data from one place to another place, and that's all. Yeah. But to achieve this, to make this data movement, data transformation, data copy, however, we have plenty of different tools and technologies created. Here I enlisted several of them. There are not only TLLT, also like we have Airflow here, like orchestration. So somebody or something, or like data flow, something should trigger your pipelines, your ETL processes, and this is the orchestration tools. Most commonly used in nowadays tools are Informatica, SSIS. If you're talking about non-cloud, yeah, SSIS could be mentioned, Talent, Pentaho, Matilda, etc. Oracle Data Integrator. If you are talking about clouds, as I said earlier, every of three major provider has the components created for data integration. If you're talking about AWS, it is Glue, or it could be EMR, or it could be even a container application using Spark if EMR somehow doesn't fit us, etc. If you're talking about Azure, so ADF, why not? If you're talking about GCP, so GCP has also some tools for data loading for ETL processes. This is about ETL and orchestration. If you're talking about visualization, Tableau, Power BI are most commonly used here. Gartner Quadrant says that Microsoft is the leader here in BI, but BI here is not only the visualization part. Under BI, business intelligence. Um, Sometimes it is mentioned that it is the whole area from just to represent the information, yeah, not only just visualization, but sometimes it is just visualization. So Microsoft, it is Power BI here. We can use here Tableau also, yeah. So Microsoft, let's say Power BI, Tableau, and we here Click as a leader. So three major leaders here, and besides that, many more. And you can choose any tool for learning, for education, but it is better if you have two tools instead of one. First, to compare it and to understand the limitations and the benefit of each other. Yeah. So probably Power BI is a good to start. Probably Tableau is a good to start. There are different companies, different customers which have different tools. And as I said, Microsoft, AWS, by the way, also has visualization tools, QuickSight, if I'm not wrong, but it's not so widely used. I believe it is here. Yeah, here at the picture here, this one. So, and GCP has Looker. No, the GCP has Looker. Google has Looker. Yeah, so Looker as a visualization tool here. Where is it? I believe it's under Google here. So this is definitely should be encountered to start with. Regarding data storages, of course, I mentioned Postgre, also I mentioned Oracle SQL Server. Yeah, besides that, we have many of other data warehouses and databases like Teradata, MySQL, let's say. NoSQL database like DynamoDB, MongoDB, and others. If you're talking about cloud, let's say I mentioned Redshift. In Azure, we have Synapse. In GCP, we have BigQuery. Besides that, we have great database called Snowflake, which also could be used as a data warehouses. And besides these three areas, we have plenty more companies from cloud providers or not. If we are talking about cloud, S3, let's say, or RDS for storing this data, for creating the relational data storages here, or NoSQL databases also. Every cloud provides this information. So definitely you have to be able to understand it and learn that. Um, to sum up, what is data analytics engineering? Data analytics engineering is the process of processing the data from the very beginning, from the data sources through the data warehouses or other data models till the data visualization. So this is the specialist who finally creates the valuable product to business, and using this product, business understand these insights and different areas. Thank you for your listening. I am ready to answer questions, if any.
Thank you, Pavel. It's a really great presentation, and our listeners already curious whether the presentation will be shared. So I will tell everyone once again, I assure you all the presentations will be on our via community page with this meetup. So because there are a lot of very useful links in your presentation. So
Mhm.
thank you very much. And what should I start with the questions? Of course, there is a lot of questions about different spheres because it's quite understandable. What is the visualization part of analytics engineer? It's creating dashboards, right? But what about this integration part?
Mhm.
Is there any difference between mm, data analytics engineer and data engineer?
Yeah, of course, there is a difference. Data engineer, data software engineer, or we can call it in our corner big data, yeah, is the engineer who works with the data in the big amounts, yeah. So usually they not only, but they use Spark like a framework to process big amounts of data. So parallelization, different nodes, etc., to create this huge amount of data to bring it from this one. Of course, they have the similar technology like ETL, yeah. So there is a source. Data should be transferred from the source to somewhere, probably to data lake, and after that should be analyzed. Sometimes we are working in pair. Data software engineer could create a preliminary result for us. Let's say they move data from the huge sources, they create Parquet files for us as data analytics engineer, and we use these Parquet files as data sources, and we also create the transformation and create data warehouses. Data software engineering don't create data warehouse like in Redshift, let's say. Yeah, so they don't create tables with these different structures, the relations between tables. They don't populate these tables because this is data analytics engineer work. Data software engineer can create data lake, for instance, with semi-structured, structured, probably unstructured data. And on top of this data lake, data analytics engineer can proceed. Yeah, so we are working closely, and we have also something in common, like Python, as I said. Data analytics engineering can use Python, the same PySpark. Uh, Most often it is the PySpark SQL because just knowing SQL, you can create the transformation. That's pretty cool. But that's all. Yeah, regarding this using of Python. Most commonly, data analytics engineer use ETL tools, just clicking mouse. Yeah, Informatica, good example, EDF, etc.
So the difference is the data analytics engineer won't necessarily use Spark, right? But
Definitely. Yeah.
apart from data engineer, he or she will need to model warehouse, right? To know all these facts and dimension tables, etc. Right?
Yeah,
So it's more about modeling.
from my point of view, data software engineer uses mostly like programming languages instead of frame. Of course, they have frameworks, a lot of them. But for instance, I cannot imagine data software engineer who doesn't know Hadoop. Yeah, and there are plenty of data analytics engineers who have no idea what Hadoop is. That's kind of the difference between these two.
That's good news, right? You don't need to know Hadoop to become.
Exactly. Yeah.
Uh, let's say you have already mentioned separate courses, right? And
Mhm.
what if I already know some things from what you mentioned? If I already have some skills that were mentioned, how can I become a data analytics engineer?
Yeah, as I said, you have to understand what is closer to you, data integration part of data or data analytics and visualization. For instance, if you are, let's say, if you are business analyst or BI analyst, yeah, probably data visualization is close to you because there is no coding at all. Except if, okay, there is coding. If you're talking about Power BI, let's say, it also has a built-in language or model like DAX, etc., where you can write functions, etc. But at the simple level, you will create the same visualizations. If you are from data software engineering world, or if you're a database developer, probably data integration as a starter is good. You have the similar, you have the create SQL scripts, tables, procedures, functions, etc., and it will create your transformation to the whole data analytics engineer more smoothly, I would say.
And we have more questions in our YouTube chat. What is the next step for ex-database developer, OLTP, who is looking to transition?
Yeah, that's a good
Um,
question. As I said, it is the grade. So let's say we have a former Oracle developer who works on an OLTP process. Yeah. So first, this person definitely have get more knowledge about OLAP system. Yeah. How they differ, what do we have here? For instance, if OLTP developer preliminary works in third normal form normalized tables, so in OLAP you can have one plain table. Why not? Yeah. So and it works or whatever. Different methodologies to create data models. After that, this person could be applied to the role of data warehouse developer who creates model, who creates like say table and creates views with transformations, because there are many different approaches, as I said, ETL and ELT processes. So if you're talking about ELT processes, transformation here is made by data warehouse possibilities. Like say if you're talking about Oracle, so PL SQL as a procedural language is the responsible for transformation. And every Oracle developer is able to work with that. I'm talking about the OLTP. So that's the good start to become the data analytics engineer, data integration engineer here. Just work on these projects where there is a ETL developer needs. In case of a ELT model here. After that, of course, ETL could be added, just adding Informatica to populate this table, etc. So his knowledge will be expanded in this way. That's a good question. The common case when a former the database developer became data integration specialist. It is easier to transform.
Thank you. And since we are running from our time, just the last question. You mentioned the requirements for middle and senior data analyst, but what are the requirements for junior data analyst?
Yeah, that's a good question. So I believe if you're talking about junior, if you're talking about a database developer, it could be also be junior. In case of data integration, what part of work could be done by junior? Database model, let's say creation. I'm not talking about table population. Informatica pipeline, why not? If there is no so complex transformation, you can create just data transformation from one point to another. It could be done by the junior developer here. Uh, when we are talking about junior and the middle, of course, we have, if you're talking about EPAM, we have different matrices which can compare and distinguish one out of each other. But it's not too hard to become a junior in data analytics engineering. in comparison of data science, probably, yes, or something like that, because just good knowledge of SQL sometimes is enough. So, and that's a good point.
Thank you, Pavel. Thank you for your presentation. Unfortunately, we don't have time to, we have more questions in our YouTube chat, so maybe they will be answered later. And please stay tuned. And our next speaker is Igar Nakhvat, who will share an interesting story of cost optimization. And Pavel, thank you once again. It's a very
Thank you a
interesting
lot.
talk. Thank you.
Hello, everyone. My name is Igar Nakhvat, and today we're going to talk about optimization. During this talk, I will cover storage and compute optimization on Amazon EMR infrastructure that helped to decrease almost $1 million during a year. Let me do the quickly self-presentation. I'm lead software engineer with more than 10 years of data engineering experience. I've started my career working with a single Oracle DB instance. The physical machine was located in the same office. It was like 20 meters away of my desk. Then I switched to on-premise Hadoop cluster. It wasn't located in any cloud. It just was a huge data center, and it takes months to buy and install new hardware for the project. And now I work with the multi-cloud solution. Our optimization presentation, we will start from the use case, where we'll describe the technology, infrastructure, and so on. We're going to talk about batch processing. So it's like a pretty standard use case where we have different data sources. The main one is Amazon Kinesis, the message broker. Almost all data comes from this resource, but besides Kinesis, there are a number of relational and non-relational resources. In relational resources like Postgres, there are some financial data like transactional, and Mongo contains different collections. All this data goes to Amazon S3 through the ETL process, so all data is stored on Amazon file system. And there are two main processing languages, technologies, frameworks. The first one, this is Hive, and the second one is Apache Spark. These two execution engines are used to populate the data marts based on the raw data on Amazon S3. So both engine looks on the file system directly. And data marts is used by analysts, by visual reporting, which is Tableau. So some dashboards are used by managers who don't have access to Hive or other SQL engines, so they use Tableau. And there are also analysts who can work both with Tableau and raw data in data marts. In general, there are more than 10 engineers who support the current infrastructure, ETL, all engineering stuff. And there are more than 20 analysts who create data marts and use infrastructure as well, and more than 100 the end users who can only view Tableau. So that's our test case. As I mentioned before, the optimization consists of optimization strategy consists of two main parts, storage and compute. And we will start from the storage and using features that are provided by cloud provider Amazon. Any talk about optimization, storage optimization, we need to start from intelligent tiering. This is the great feature from Amazon, and each project that utilizes S3 should use this feature. For our case, everything was fine with that. This feature was switched on. As you can see at the graph, you can see the distribution that the expensive standard storage, the data volume in this standard storage is relatively small. So almost all data sits on intelligent storage, which is cheaper than the standard one. And the good thing that Amazon does, it all transition in the background, so we don't need to worry about it. Also, you can see this blue text. The case was more than a year ago when Amazon implemented new archive storage, and it automatically pushed the old data there, which also was really nice. You will not find on this graph Glacier, which is like cold storage. This cold storage is even more cheaper than archive one, but on the other hand, you can't read the data immediately from this storage. For some cases, it can take more than 20 hours to get the data from the cold storage, so it's not accessible instantly. And for our case, we decided that it's better to drop the data or store it as is on intelligent steering rather than moving it to Glacier. But for some cases, Glacier can be a good option also. Next topic is lifecycle configuration. It should be applied for where possible. The good candidates for the lifecycle configuration is intermediate data. It can be some staging files, logs. I believe no one needs any kind of logs older than year or even months. For our case, months is more than enough to store the logs. So everything that we don't need to store forever. For this particular case, I have created more than 60 separate lifecycle policies based on S3 prefix. There are also ways to utilize tags, so you can tag your data on S3 and then create configuration based on tag. But anyway, it's also very nice feature to get rid of unused files automatically. Next feature is bucket versioning. It's a good way to have a possibility to restore the data if it was deleted by accident. But on the other hand, this feature is not free because you need to pay for all the previous versions. That's why for our case, we created the bucket versioning, but only for 3 days. So if you drop something, it is possible to restore the data during the next 3 days. But then lifecycle will wipe it out. So if you use bucket versioning, make sure that there is correspondent lifecycle policy, because for the most cases there is no sense to store the previous versions forever. So sometime they need to be deleted after some time. And that was it regarding the built-in function. So let's talk about something more interesting, which will be new information for you. This is optimization using custom approaches. Again, I will start with like common and well-known topic, but I can't ignore it. This is data formats and compression. If we store data as a plain text, we have a good possibility. So a good possibility to optimize it. For This particular case, all data were stored by Parquet Snappy. On the graph, you can see the same file. This is parking violations that was stored with different data formats and compression. And you can see there is distribution of some compression is better, some compress better, but it takes more computing resources to read. And there are other cases, but in general, Parquet Snappy is a good compromise between the volume on the disk and the resources need to be read. So again, make sure that you use the right format with compression, so you don't store data in a plain text. So let's talk about the first good use case about the unused tables. Meet Alex. Alex is data analyst. He have been working at our company for the last 2 years, and he did a great job during this career. He has created 15 dashboards at Tableau. There are about 100 separate tables in his personal schemas with ad hoc, some aggregates, so with some used data. But then, after a while, he decided to quit the company and became a musician. What does it mean for us? If our offboarding process in our company poorly defined, and actually, me personally, I didn't have a chance to see like perfect onboarding process, we can have an issue with unused object. On the top right corner, you can see a real example of personal schema for a person who left the company. And I found about 3 million separate files in his personal schema with almost 200 terabytes on Amazon S3. For the company, storing such data cost almost $10,000 per year, and this data is used for no one. So it's like deprecated data. And our goals as data engineers to get rid of such issues, we can do it in 2 ways. The first way is more managerial, so we can define the process properly, set up some kind of system, or alternatively, we can do it into engineering way, because there is a way to find such cases without even knowing that person has quit the company. There are S3 access logs that can help us to find the files that were used for no one. And also we can cover the next case. This is unused tables. For example, when the business logic is no longer valid or used by someone, we can have a dashboard in Tableau that is no one view. For example, in Tableau, you can see the number of views for each dashboards. And for example, if you find a dashboard that has 1 view per month, it is a good way to raise a question: do we need at all these dashboards? Probably the logic is incorrect, or the person who has created this table got a promotion and he no longer needs this data. So there may be a lot of options why do we need this object anymore, but it can be an issue, especially when our project lasts like 5 years. So it's pretty huge period to accumulate such branches of unused logic, and that here we can do our job, data engineering job, and find such objects, review them, and delete them. Other case regarding the files, this is orphan files, and under this term orphan, I mean files on our file system. This is S3 or HDFS without any metadata in Hive metastore. So, for example, we have a bucket, and in our buckets, all data have metadata in Hive metastore because we use relational tables to read the file. So if we don't have any metadata in metastore, that means that we need to delete these files. The ways where these orphan files can arrive, it can be using external tables, and if we delete external tables and do not clean location manually, the data will sit there forever without any chance to be read from the SQL engine. And also this is staging data, temporary data. We can apply lifecycle rules, as I have mentioned before, and also S3 access logs can help us to define this object. For the orphan files, I have created a custom Spark job that reads the data from Hive metastore. On the other hand, it reads data from access log, and it combines the two data sets, and it shows the difference. So I can find such orphan files and delete them later. So to do a quick summary, use intelligent tiering is like the must option. Create lifecycle rules where possible, use data compression, and create a framework that will help you to find unused tables, data orphan files, and wipe it out. This is the real example after the optimization that took almost a year. Here you can see the graph. The blue line shows the total size in petabytes. There is no distribution between S3 tiers, so I have combined all tiers all together, so it's cumulative data size. And you can see the huge drop here at May, where lifecycle rules were applied, and the first way of finding and eliminating unused tables and orphan files were made. And also there was a second wave on finding and deleting the unused files. As you can see, during the year, our data warehouse get rid of 3 petabytes. So the incoming data volume still the same. So here you can see from May till November that data is growing, but we have deleted more than arrived, which is also a very good result. Here you can see the most, I believe, interesting part. This is cost. So it's not about data volume, it's about the real money. I have blurred all numbers, but each point for each month stand for X $million. And you can see that the cost goes down during the life cycle rules, unused tables here and here, but there are also a very huge impact that were made by Amazon S3. It has provided a huge discount, so the all cost for all tires in our region went down. So that's why there is a big drop on the graph. And on December, we have also a very huge drop down because of implementing new archive storage. It was really hard to define the ratio because during the same time we have deleted a lot of unused tables, logs, and so on. But in general, December is 36% cheaper than January, which is also a great result, and we can see that the trend line goes down. So that was about the storage optimization, and we can move on to the compute optimization part. This part, I would like to start from the physical infrastructure. If your project is old enough, there is a high chance that Amazon released the newer version of EMRs, and newest version allows you to use next generation of EC2 instances, and always this new generation are better than the previous one. They have more CPU, more memory, and they cost less than the previous one. So the first step is to get the latest version, upgrade your instances to the latest available generation. This is a good starting point. Next one is logical organization. For this particular case, I have distributed the workload across 3 main clusters. Before, the workload were distributed like randomly across even more clusters, but there were no logic at all. So I have selected 3 main clusters. The first one was only for hourly jobs, and for our case, we have hourly jobs that are running during the whole day. So it's each hour we have something running, and it's pretty flat workload. It's very predictable. The next cluster was designed for the daily workload. It's only for daily jobs and takes about 15 hours to calculate all the data marts for the last day, and we don't need to have a huge cluster for the rest of the day. And the third cluster, I called it heavy. I've redirected there only few jobs. As far as I remember, it's only 5. And these jobs are pretty unique. They run one by one, not in parallel, consequentially, and they consume all available resources, and it's pretty slow. It takes more than 2 hours. And I've decided that it will be better to run them on a separate cluster so they can't interfere with daily and hourly workload, and I can apply different lifecycle rules and scaling. So this is our next topic. There are 2 main options regarding the scaling in EMR world. The first one is custom rules. So you can define a rule based on various options like free memory, number of containers, and so on. The good thing about the custom rules is that you can tune them very precisely, and this is the best option for some edge cases. But in general, they are more harder to set up. And if you did wrong configurations, for some cases, instead of decreasing cost, your bill will be increased. And the next option is EMR manageable, managed scaling. It's easy to set up, best for the general purpose, but again, for some edge cases, it can be worse. For our case, I have created the custom rules. As I have mentioned earlier, we have 3 clusters: hourly, daily, and heavy. For the hourly cluster, I did not set the scaling policy because the workload was flat. But for the daily, I have provided scaling out policy based on available memory. So as soon as the percent of available memory is less than 15, we're going to add extra portion of free nodes. And as soon as there are no more application, we are going to aggressively shrink down our cluster, because we know that daily calculation has been ended, so we don't need to keep resources anymore, and we can quickly squeeze it. Almost the same options were granted for the heavy cluster, but in this case, we need a lot of resources immediately. So as soon as any application arrive to heavy cluster, we want, 400 nodes to be available. So very aggressive policy when we have at least one application, and when there are no more application, we don't need the resource, and we can shrink our cluster back. The next part is spot nodes. Spot nodes is a good way to pay for the same instances less, but there is a risk that Amazon will borrow it for you back. So here at the graph, you can see the frequency of interruption. There is a separate page on Amazon documentation where you can see this rate for the different instance types. As you can see here, our best option is M5D because the chance of interruption is less than 5. And we probably should avoid D2 instances because the chance is too high. I've started testing spot node ratio from 20%. So 20% is spot nodes, and the rest part is a standard on-demand node. But the cluster worked not so stable, so that's why I've decided to reduce the number of spots nodes to 10, which is worked fine for hourly and daily. And for the heavy cluster, I've decided to leave it without the spots nodes because the price of interruption is too high, and it's better to ignore this risk at all. So once again, spot nodes is a cool feature, but you need to test it for your particular case because sometimes reliability is more important than the price. Here, let's talk about the compute optimization results. On this graph, you can see the daily trending. So this line shows how much all EMR cluster cost for one day. I have also blurred the cost. It's not millions, it's $1,000 per each day. And there are also 2 lines. The first line, it's like the blue one. This is our baseline. So it's like situation that we have right now. And the green line, it's X. This is our goal. So our goal is to push the daily trending graph below this x level, so we can save more money. The main line is not flat because of auto-scaling rules. You see that sometimes it goes up or sometimes it goes lower, and it's hard to define like the base layer. So I have choose one 7 days window in April, and I have calculated the amount of money that we pay for this 7 days window as our baseline. So all savings in percent, they will be calculated based on this period. And this is our picture after all optimizations. Here you can see the same green line. It's our goal, X dollars per day. And you can see that the graph went below this line during the same 7 days window in row. That means that our approach works really fine, and this is like the real results from production data warehouse. In general, the overall costs reduced by 60% with no negative impact on ETL. So data team provides the data into the same constraints, but company pay less for the same result, which is really good optimization. In this presentation, I didn't mention EMR serverless. This is a relatively new feature from Amazon. They have invented it probably a year ago, so it's pretty new. And this is our plans for the future to try out serverless, and it seems to be it can be even more effective than the previous approach when you need to create separate clusters. So it's like plan for future, and for you it's also a good topic that you need to keep in mind as an option that can help you to save the money. And that's it from my side, so we can move to the questions.
Yeah, thank you, Igor, for this interesting topic. Yeah, a lot of material. So also we have questions. So maybe first about those S3 optimization. So you mentioned about this artificial intelligence tier, and does it mean that I should always use this AI tier, or are there any cases when I should use standard tier?
I believe if we're speaking about the project that relates to data storage, so it's not like some content delivery network or I don't know, a web application where amount of data is relatively small, but we need to get the data really fast. Then I would say that this intelligent tiering is a must feature for any project that relates to data warehousing, because we have a lot of data and it's fine to wait I don't know extra 1 second or 1 or 2 seconds to get the results. So it's good balance. You pay less, but you wait more. But in our world, 2 seconds is fine. If we're speaking about ad hoc analytics, so it's not something that connected to online processes where you need to keep low latency. So if the latency is not a problem for you, then yes, intelligence tiering is must-have feature.
Also, you mentioned a lot of information from different for different AWS resources, but are there any advisor in AWS that can help to reduce costs?
You know what? For that particular case, the heaviest part was connected to monitoring and inspecting the data warehouse, because provider can give you some basic stuff like use intelligent steering, lifecycle configuration, but they will never point your attention to things like, hey, we have 100 terabytes in this folder that are used for no one, so probably you can delete it. So I think that they can provide you some general guidance how you can do this, but the crucial benefits you can get only by yourself and knowing how to do this and knowing your particular case and your infrastructure and data warehouse.
Yeah, and also you mentioned about changes in infrastructure to decrease costs, but were there any changes in pipelines, jobs itself, in code?
Yeah, that's also a good topic because ineffective code may also cause spending extra resources on computing, but I did not mention it here because it's more connected to a business logic. If analysts using partitioning and other basic stuff, we can think that this layer is fine, and we can dive into more engineering solution. But yeah, the business logic, the code, it's also a way where you can optimize and save the cost also, but it's not covered here. It wasn't covered here.
Yeah, you also mentioned how you optimized costs, but yeah, it can bring performance issues. So how was it tested? Did you create like a separate cluster or separate AWS account with all this stuff, or
no,
did
it's
changes like?
yeah. So all changes were applied to the production one, but it wasn't in one step. So it took me about 3 months to apply all the steps that I talk in presentation during this period. So I was moving by very short step, monitoring daily the workload, the ETL, because I didn't want to break anything. So it was like step by step actions, but on the real environment, and it took, as I mentioned, about 3 months. So everything was in a production, but I moved very slow and carefully with all these changes.
Okay, yeah. Thank you, Igor, for your presentation. Really interesting. So yeah, it was a presentation how to reduce costs. So I ask you to stay tuned. And next presentation from Aleksandr, he will share his experience of creating, of using big data with no costs. So this is the next level. So stay tuned. Thank you, Igor.
Bye.
Bye. That's again Winter Data Meetup. And next speaker is Aleksandr, who will share a great story about creating a big data, using big data with nothing. Yeah, Aleksandr, floor is yours.
Yeah, thanks, Alexander. And thank you very much for the announcement. Yeah, it really sounds great. So I'm going to tell you a few words about a very interesting story about creating great big data solution almost out of nothing. So you can see the agenda, and I will introduce myself, tell some phrases about the story itself, and share some ideas how you can use some things, some interesting things in your own projects to make it successful, and so on and so on. It will take about 25 minutes, so let's start. Okay. Yeah, just let me introduce myself. My name is Aleksandr Shovkovyi, simply Alex. Shovkovyi means silk in Ukrainian, so it would be easier to remember if you want. I'm a delivery manager. I work with EPAM for 7 months, but I have a pretty big experience in IT project management. I work with different companies in different industries, so I have some interesting stories to tell you. And before we start, the title of the presentation is Big Data from Clay and Sticks. So could you please put your answers in the chat? What stands for clay and what stands for sticks? It would be interesting. I will tell later, but it would be interesting to see your answers in the comments. Okay. So this story happened in Russia in 2014. It was pretty cold autumn of 2014. I joined a very big telecommunication company as an IT project manager, and there was a pretty simple goal. We just want to build a centralized data warehouse with many data sources and with many users, and to have a very nice solution that will work fine, and so on and so on. Yeah, sounds very interesting, and for the first time it looked pretty easy to implement. But when I started working for this company, I realized that there are some problems. First of all, there was a real data warehouse zoo. A lot of different databases, business intelligence tools, a lot of teams, local and contractors, vendors, many users with their own teams, and IT managers, different budgets. So it was a real mess. And the idea was to get rid of all this stuff and have one single beautiful solution. That was, the first challenge. The second one was even more interesting. When I joined the company, the situation in the project changed dramatically. It was no more an IT project. It was managed by the strategy department of the company, and actually there was almost no vision of the solution itself and at the same time, my IT boss who hired me, he left the company just in a couple of weeks after I joined it. My department was closed, so I was in the middle of nowhere with with absolutely new environment, new customer, no support from the IT management, and so on. So that was the second one challenge. And the third one was that there is almost no available hardware. So if you want to do anything, you need to purchase hardware. There are no cloud solutions. You need to find budget to walk through all these purchase procedures, and it can take months to get just a virtual machine for any purpose. So that was the the third challenge. But as Benjamin Franklin said, no gains without pains. So do we have any answers for data? Clay, developers code sticks. Okay, nice. To join some pieces together, make them connected. Almost there. Yeah, almost there. Here I name Clay. Clay stands for the team, for the people that work with us, and it's very important to have a motivated customer, data engineers that have a relevant experience, and the infrastructure team that is ready to help to make some interesting things out of nothing. And of course, project manager, who can gather all these people together and make it happen, actually. So that stands for Clay. Clay means people and the team. Just a few words about the business idea itself. We found a very interesting customer who worked with IP television, and he had a very interesting business idea. He said, well, we have data about our users of IP television. We know what they watch and we know what they buy. So let's find some users that watch the same things as those who buy some interesting movies or something like this, and we'll propose them that the users with the same interests to buy the same video on demand content. So that was the idea. Very simple. It looked very interesting, and actually, it was simple. It was achievable, and so on. So it was a very nice customer who knew what he wants. The second one, sticks. Stick stands for the hardware itself. So if you have people in place, but you need resources to build the solution. So we find very nice infrastructure guys, and we ask them, okay, what can we do? We need a cluster. We need a cluster to collect all this IPTV data and store it and process it. So they said, okay, we have a dozen of decommissioned servers, and you can use it, no problem. Just go to the data center. They're going to be utilized in a couple of months, but go ahead. You can try to build your solution using these servers. The funny thing was that they were a little bit damaged, and we tested some of them, and they worked fine, but there was lack of random access memory. So we found some random access memory, used random access memory on online marketplace, and it costed us about $150 So we bought it jointly, and that was the only one actual purchase in all this pilot project. So it was not absolutely free, but yeah, almost free. When we put all these things together, we installed this used random access memory and sent the servers to the infrastructure guys to install them. They sent us a couple of pictures asking, "Are you sure we can switch it on?" Because they were really damaged, and yeah, hopefully they worked fine. They worked fine. I'm not going to go deep into the solution architecture, but just in a few words. We have IP television platform on the left side. It produces logs in CSV format. These files are stored in HDFS in Hadoop, converted to Parquet format, and then the data is processed using Hive and then transferred to campaign management system. So very easy, very simple, and it worked. Actually, it worked. We had a very nice team of data engineers from our company that worked with another project, and we just asked the guys, could you please help us to have this solution developed? Yeah, and what do we have as a result? We have a very small but functional Hadoop cluster. We are collecting data from the APTV source, and we provide recommendations for the campaign management. And we saw that people who were recommended to buy some video on demand content, they really did it. So we had a real business case working. So it was amazing. Almost out of nothing, just an idea, some guys who helped with the servers and the team of data engineers. And here we go. We have the first business case really working on almost out of nothing. So that was really great. The second thing was that we proved for ourselves and for the management of the company. It's a really big telecommunication company. You know, a lot of vendors come and say, just buy this appliance and you will be happy, and so on and so on. We proved that Hadoop solution and MPP solutions are really the best approach for such a big company, because they're effective, they're cost effective, and they're reliable, and they really work. And finally, we developed a strategy for the whole centralized enterprise data warehouse based on open source Hadoop and MPP solution with very low price and almost independent from the vendors. And by the way, here on this picture you can see Sofia Bukovets. She's one of my favorite beach volleyball players, and we were excited almost as she was after winning some matches. Okay, and that was the pilot project. It was really successful. The team was very excited. The business was very confident that IT guys, they know what to do, they know how to do it, and they proved that they can make it happen. So in the end, almost in a couple of years, we had a really big enterprise data warehouse with more than 1,000 of business users, more than 10,000 of dashboards and reports, more than 100 of source systems. And if you remember, we started with only a dozen of used partially damaged servers, and we came up with a cluster of almost 200 servers and 11 petabytes of the total storage. And what's more interesting, local in-house team of data engineers, of more than 50 data engineers constantly developing this solution. So it started almost out of nothing. Just a couple of guys, like-minded persons from one of that department, and $150, and that's it. So that's how it actually happened. So to summarize all these things, just a couple of items to highlight. The first one is a highly motivated customer with a clear goal that knows what he wants. That's very important. It's almost impossible to build some kind of an IT solution without clear business goals. If you have clear business goals, you will be successful. And the second one is the team is finding like-minded people, share ideas, be brave, and of course stay positive, inspire your team, inspire your customer, and work hard and make it happen. So that's the way how it really worked. Okay, and just a couple of quotes from Benjamin Franklin. This is not something new for anyone, actually. Yeah, we know that we need people, we need to be active, and so on and so on. But sometimes we think, okay, yeah, it's a big company, it has its own rules, it might not work, and so on and so on. You should just try. You should try, you should propose your ideas, and this is the only way that makes your work interesting and your projects successful and valuable for the users, for the stakeholders, and for yourself. So start from very small ideas and just work hard and make it happen. So that's the final slide. And if we have any questions, I would be happy to answer them.
Yeah, thank you, Aleksandr. Very interesting topic and very interesting presentation. So yeah, we have a couple of questions, and yeah, have you used Cloudera version of Hadoop, or you built everything from scratch from Apache sources?
Yeah, we started with Cloudera version of Hadoop. There were even ideas of using Impala instead of Hive as a Cloudera native tool for querying data. But later we switched from Cloudera to Hortonworks because Hortonworks, it worked really well with Greenplum at that time, and Greenplum was the NPP solution that was used.
Mm-hmm. And so you told that you found a team, or you already have a team who agreed to develop this solution. Yeah, that's really great. It's very hard to find motivated persons who will be ready to learn maybe something new. So yeah, how long did it take for them to learn Hadoop and yeah, to be ready to create some solutions? Or it was in
Yeah.
parallel?
The thing is that these guys that we found as the data engineers, there were only two guys for this pilot project. They were experienced Hadoop engineers, and they just worked with totally different projects at that time. They were building an internet search engine that unfortunately died. But the thing was that they were really great and experienced and very skillful data engineers. So yeah, they made really great thing just in a couple of weeks. So the solution was developed in a couple of weeks.
So and you and okay, you mentioned about solution in a couple of weeks, and how long did it take for you to create this infrastructure or yeah, find all these servers and set up everything? So yeah, looks like it's very big piece of work.
Yeah, it was a big piece of work, and if you do it following all the procedures, it could take more than a year. But we agreed with this or that, with the infrastructure management team, and with many people. We had to interact with them, to inspire them, to tell how it will be great to make such wonderful thing in this huge company. It was like a startup in a real big company. And in general, it took about 1.5 months from start up to the end. And maybe 1 week, it could be 1 week less if there will be a random access memory in place. But we had to buy it in a marketplace, so it took a little bit of time to meet this guy near the underground station to pass him this $150 and so on. That was the most unusual procedure in all this pilot project.
Mm-hmm. Okay, got it. Yeah, thank you very much, Alexander, once again for a very interesting story. Yeah, so and for those who are listening to us, I want to invite you to the next talk. So Liudmyla will share with us best practices for Power BI development if you're using Power BI or working with it. So that's what definitely you should listen to. Yeah, thank you, Alexander, once again. So stay tuned.
Thank you. Bye-bye.
Hello, everyone, and this is Winter Data Meetup from Zen Community. Our speaker is Liudmyla Yukhno, and she will share with us the best practices for creating valuable, supportable, stable, and optimized BI report. Please don't forget to ask your questions in YouTube chat. Hi, Liudmyla. It's nice to see you. The floor is yours.
Hello everyone. My name is Liudmyla or just Luda, and today I'm going to speak about best practices for Power BI development. Best practices is a very broad topic, so I want to mention that practices I'm going to speak about are mostly focused on report future maintainability. I'm not going to focus a lot on report performance or design because there's lots of information in the internet about it already. But my main idea was to collect some practices that should help developers to create a report that will be clear, understandable, and easy to maintain in future, including for people who didn't work with this report before. Some of these points you can easily find in most of guides for Power BI developers. Other ones are built on my own experience. And I wouldn't say each of them is strongly necessary for any Power BI report. It's better to be considered as a list of ideas and tooltips that may simplify your development process. The more huge and complex report you build, the more profits you get from using these practices. A few words about myself. I'm data analyst and data visualization specialist in EPAM. I have been working in Power BI over 3 years, and my experience counts multiple various reports with different data models. Last autumn, I gained Microsoft certificate to confirm my qualification in using this app. And what is Power BI itself? Power BI is a data visualization software developed by Microsoft. With Power BI, you can easily create complex interactive reports, share them with users, view data from different devices, maintain a refresh schedule, access layer, and many other things. Process of report creation starts from data preparation. You connect Power BI desktop to needed data sources, transform them somehow in Power Query if necessary, and after that build your visualization and publish results to Power BI service. As I'm speaking about report maintainability, my main focus will be on practices you implement directly in Power BI desktop. But of course, sometime I will touch sources and service side as well. So let's start from beginning and speak about data structure practices. First of all, and as the most important advice in all this presentation, I need to say, make your data transformation as close to the source side as it's possible. In ideal case, you shouldn't do any transformation in Power Query at all. If for some reason you can't do all needed transformation directly in the source, which is a pretty common situation, and you think about if you need to use Power Query or calculate some columns in DAX, Power Query almost always is a better choice. Except this, you still may shift the load of some transformation steps in the source side to reduce the load on the computing power of the Power BI. If you connect to relational databases, open data feeds such as an Excel file in SharePoint, Exchange, or Active Directory, Power BI automatically create native query to the source and load to the report only result of this query. This feature called query folding and support not all possible Power Query transformation. So it's better to put all unsupported ones in the end of your transformation steps list. Some helpful practices for your reports. If you know that source of your data periodically switches its location, you may create a parameter and put direction to this source in this parameter. Parameters are available to change directly from Power BI service, so you won't need to republish your report from desktop each time when source has been changed. One more way to simplify your development is to set up incremental refresh, because it decreases time of data refresh both in Power BI desktop and Power BI service side, but like in a different way. You will see in Power BI desktop only a few data that are filtered by parameters range start and range end, and it will be enough for you to test your report. But in Power BI service side, you will see all needed data and refresh only some set, some piece of data that you set up. For example, like last 3 days. Limitation of this method is that your historical data won't be appeared updated automatically in case of any changes. So incremental refresh doesn't fit you if historical data in the source changes pretty often. And you also won't be able to use incremental refresh effectively if your data doesn't support query folding. And some features that may help you to quickly analyze your data quality is data preview features, column quality, column distribution, and column profile. Just don't forget, if you use these functions, features, switch column profiling mode from first 1,000 rows to entire data set in the bottom of your screen. So what's better to avoid when you're working on the report is firstly to enter data directly in Power BI. This feature may be used for some really small tables and
Thank you,
as
Alex, for the
example,
introduction.
sorry? Okay, for example, list of measure units needed to provide users a possibility to switch between kilometers or miles, or different currencies, or so on. And these several values are the only one thing you entered table has. But for any biggest table, it's better to create something to connect to it, because it's really unpleasant experience to make any edits in such tables. Once in my practice, I was told to enter dimensional table with France, regions, and districts directly in Power Query. I agreed because, I thought, what can be changed in the list of country regions? You can't imagine how many things actually do. I needed to replace this table about 5 times, and finally it was just moved to Excel file in SharePoint as it should be done from the beginning. So just don't. Next piece of advice is really simple. It's better to load needed data in the future than collect extra data you don't use in the report. And if you need some table in your data transformation, but you don't use it in visualization, just disable its loading to the report. It still be there for your Power Query, but it won't blur your eyes, like, or it won't increase the report size in your report finally in Power BI. And the last point in this block is if you need, for some reason, several copies of the same table with different transformation steps, for example, to create dimensional tables that are not presented in source. It's better to use reference instead of duplicates where it's possible, or to create interim table where you collect your data and connect other tables to this one. Next advice is to make your data as reusable as it's possible to avoid double work. Power BI provides a lot of ways to simplify your development processes and set your data pipelines, so it's just a good idea to use them. Okay, and the thing people don't usually pay attention on, but that may help a lot when you try to understand what's going on in the report, especially if you've never seen it before. It's naming. Table on the screen is just my own way to sort things. You may create your own, but when your naming follows some rules, it's much easier to navigate in data. It also should be the same set of rules for each report in ideal words. So, great. We're done with data transformations. We can close Power Query and finally start building the report. Firstly, I'd ask you to open model view and maintain your data schema. Just drag tables in the way that the viewer could easily understand connections between data. Which tables are facts and which are dimensions. The easiest way to familiarize with a new report is to check its schema, so it should be as clear and understandable as it's possible. I also advised you to use star schema and one-to-many relationships instead of snowflake schema and many-to-many relationships. And if it's happening that you need to use many-to-many relationships, ensure that you clearly understand how it influences on your calculations context. And configure single direction filtering to avoid mistakes in calculations. Technical columns are used in relationships between tables, and sometimes it's needed to provide exact calculation logic, but they are not used in visualization building. So it's better to hide them to clear your report view from extra data and simplify navigation during the report building. You may group your measures and columns inside one tables to logical blocks called folders. That's just a way to simplify navigation in data a bit more. Sometimes data are needed to be additionally configured. For example, if you don't configure your country column and as country data type, they might be incorrectly displayed as on a map visuals. For example, Georgia, a country, could be interpreted by Power Query as Georgia state of USA. It won't be if you just say Power BI that's strongly countries list. And it's also useful to configure numeric data to show and summarize it correctly all over the report. And if you have hierarchical data to show, it's a good idea to create hierarchy and put it in all visualization where it's needed, instead of creating hierarchies each time in visualization parameters. Talking about calculations, the main idea is to make them optimized and easy to read. For example, calculated columns take up space in memory, when measures save only logic of calculation and are calculated in RAM in context of each particular visualization. Variables not only increase DEX formula performance, but also increase intelligibility of the formula and make it easier to read them by other developers or even by you after a few months. And creating a separate table to put all your measures there is an elegant way to simplify navigation between them. And of course, just a few things about visual design. First point is something that can simplify your development process a lot on the start. Every company has its own design standards, so creating of a new report always starts from such things as adding logo, headers, background, or something like that. You'll probably use theme files anyway, because almost all companies have their own color standards. But don't forget that you may save in this file not only palette, but also fonts and sizes for different types of text and so on. But if you know that all your reports have the same canvases that you set up every time the same canvas when you start a new report, you can save this canvas as a template file. This file doesn't contain any data, but only preset of visual elements and theme. So you won't need to start it manually anymore. Another good idea is to set up images for page's background. It will clean your canvas from extra visuals, such as shapes, images, or text boxes, and affect both your navigation between elements and page performance. Next one's practices are mostly, but not exceptionally, about report maintainability in the future and about how to make it easy to understand what's happening on the page. That's not so necessary when you have just a few visuals on the page, but if you build complex pages with multiple bookmarks, swiping charts, hiding elements, and so on, you'd better not hesitate to make a few extra moves and provide a possibility to navigate in all of them, not in like blind manual way, for yourself and also for other developers in future. In addition, just want to pay your attention on such powerful features as built-in performance analyzer and possibility to expand Power BI's feature set even more by adding multiple external tools available on the internet. Of course, you need to align using of these tools with your customer policy. There are some examples of tools that I used in my work. Dex Studio may help you to build powerful, optimized DEX calculations. Power BI Helper have lots of features, but as I understand, it wasn't updated for a long time, so not all of them still work properly. Why did I add it here? Because that's the only one tool I found in the internet by today that can show you all unused data in your report to clean it up. For example, when you created some calculations while you developed the report, but don't use it anymore in any visuals. Tabular editor is an instrument that can empower your data modeling a lot. Just one of examples how you may use it. If you have some set of metrics which you need to show in several ways, for example, like absolute value for current year, for previous year, and its difference in percentage. Using built-in Power BI capabilities, you will need to create a separate measure calculation for each of these metrics. So if you have sales, amount, count of customers, and profit, you will create 9 measures to show it. But with Tabular Editor, you can create only 3 measures with logic of what is current year, what is previous year, and what is its difference. And context of metric for which it is calculated will be created directly in your visualization. And then when your report is done and published, just a few words about simplifying its future support. The most valuable point is, of course, to have up-to-date documentation for your report. Most of us don't like to write it, but I guess all of us would be happy to have a possibility to find all answers for all our questions in the one place. And Power BI files are not source code file, but simply binary files. So you can't use traditional version control system to provide its versioning. One of the way you may to use is create separate div workspace and publish a versions file there. In my current project, we combine the workspaces with SharePoint folders. Workspaces are mostly used for report testing in Power BI service side and to approve them with customers before publishing to prod. And SharePoint folders are used to store all our reports in one place and have access to their update history. And of course, don't forget to check Power BI new features that are released every month. Power BI become more and more powerful product each month, and some features that previously could only be implemented using complex data manipulations and custom visuals now require just a few clicks. In conclusion, Power BI is extremely powerful instrument, and the more you can do in it, the more ways you do have to complicate things. So just keep in mind that less is better, and few extra moves could increase the report intelligibility and maintainability extremely. To put you should try to put all data transformation outside of Power BI, and don't hesitate to use any features that could simplify the development process and save you from double working. And that was pretty fast. So thank you all for your attention, and if you have any question, you may ask.
Don't worry, we have questions, so we will need this time for them. First question is probably from your colleague. She is asking in YouTube, Liudmyla, are you waiting for a specific new feature in Power BI? Which one?
Me personally,
Yeah.
I don't think so. A few months ago, it was published field parameter, it called. And this is a feature that I waited for a long time. I even didn't know that I waited for it before I saw it, because previously you could implement something like switching between different dimensions in one chart by using like really hard way with bookmarks or some data manipulations. But now you can have these field parameters, and you may create some chart or table or something else where users could select in which dimension they want to see their data just by, as I said, a few clicks. And this is really the most like effective things that I saw last few months.
Thank you. So your favorite feature has arrived
Yeah,
already, right?
yeah, just like that.
We have more questions. For example, I am thinking which one. One question is from Sergei Antoniuk. Hi, Liudmyla. Could you share best practices for Power BI reports quality assurance? please? Maybe
Oh,
using these reports for quality assurance.
I would say that you may still use this quality check features to ensure that your data don't have like errors or duplicates or something like that. And I guess that's the most important practice to use this feature.
So you are now talking more about how you test your reports? And I think the question was about, are there any best practices for using Power BI for the purposes of quality assurance engineers, like when they prepare their reports about quality?
Oh, honestly, I'm not sure I correctly understand the question. So, is it about report on topic of quality or what? So, sorry, I just maybe
Yeah,
did.
maybe, yes. Let me read it again. Hi, Liudmyla. Could you share best practices for Power BI reports quality assurance, please? Maybe it's a question about quality assurance of Power BI reports, right? Reports. So apart from this built-in features, how do you test your report while you are ready with it, that it is like in the requirements? And do you actually test your reports?
If you talk about quality as performance, it's performance analyzer built in, is so you can check how fast your visualization loads, and if you need somehow transform your visualization to increase its performance. If we're talking about data itself, I would say that's like pretty simple. You just check your data and check if your calculations step by step are calculated in correct way.
Okay, and
So
if there
if
are some...
I ask, sorry,
No, go on.
I just wanted to ask if I answered the question.
Well, we don't know because there is a common quality assurance of reports, right? So we I think we is quality checked manually of your report? I mean, one while it is ready. Like you have some requirements, the customer wants to have some report, and before you are handling it to the customer, like you checked it, as you say, right? Or is...
Yep. We check it before we publish it, and after that, it's not like some regular practice. You check it when you add some edits in it.
Okay, so it's manual way.
Yep.
And there was some question in the beginning. Okay, let's say I watched this talk, yeah, and got interested in the Power BI. What would you recommend? Is it easy to learn Power BI? What resources would you recommend to start from?
Oh, I really like Power BI and its possibility, and I wouldn't say it's so hard to learn. If you used to use Excel, that would be pretty fast to you to navigate in DAX, which is language of calculations in Power BI. And if you want to learn it, talking about myself, my first knowledge, which was enough for me to build some reports, uh, I gained by not more than 1 month. And if you talk about some ways to learn, I would strongly recommend Microsoft courses on Microsoft Learn platform.
So just go to the site of Power BI and take that course that they have the tutorial, right?
Not Power BI, but Microsoft Learn, that have a lot of courses on multiple different topics, and for Power BI also. And that course, I guess, really great and easy to understand.
Thank you. And we have more specific questions from your colleagues, I believe. Hi, Luda. Please, any examples of successful image for page background? I can't get how it helps.
Oh, okay. For example, you have some set of forms and shapes to divide your page on different panels. And if you have a lot of these forms and shapes, it will decrease your performance of this page. So you can just hide all your visualization, keep us unhide only these shapes, open on the on the full screen your page and save this as just screenshot. And after that, just put the screenshot to background of your page. So you won't need these particular elements anymore in this way, and that won't influence your performance.
Thank you. I hope, Madina, your question was answered. And another question: when can we see right totals in table in Power BI tables visuals when average is done in rows? You can. Should I repeat it?
Sorry, I guess yes.
Yes. Let me concentrate. When can we see right totals in table in Power BI tables visuals when average is done in rows? When average is done in rows?
So you mean that you have average values in your rows, but you want to see something else in total, not average? Or if you calculate just some average value of your measure, it will be average both in rows and in total row. If you want to see something else, you can do it by DEX calculation by using some additional parameters, some additional if cases to provide your logic.
Thank you. Since the next question is, can such feature will be added in future? I think our listener maybe thinks that you are developing Power BI or can influence, write to the developers and just ask for such feature. Okay. Well, thank you for your question, for your presentation, and for your answers. And it was very helpful, I believe, like a tutorial for people who may be new to Power BI. And thank everyone for listening and for watching us. Our next speaker is Alexey Novakov, and he will share his story of data lake implementation. Thank you, Liudmyla.
Thank you all very much. Thank you all for listening, for joining, and goodbye, I guess.
Goodbye.
Hello again. This is Winter Data Meetup, and our next speaker is Alexey Novakov, who will share his real experience implementation of data lake architecture based on real experience. So strongly recommended. Yep, please.
Yeah, today I would like to talk about the data lake implementation, about the project that I was actually participating as an architect at EPAM. It's also about the architecture based on the multi-tenancy and developed on top of the AWS cloud. So a few words about me. I'm Alexey. I'm working as a data architect at EPAM. I also like functional programming and music. You want to contact me, you can also use my blog at this address at GitHub.io, where I post time by time some articles. This project is based on the real experience working at EPAM. One of the client who is a leader in stock management software, so they have a software as a service platform where we, EPAM team, were developing for them and still developing for them the data lake or / data platform. So what we're going to cover today, it's several blocks in our agenda. So we'll go through the main architecture diagrams. There's going to be a separate block about multi-tenancy. We'll also look at the standard workflows that we've developed for this data lake story, main use case, and how we've done that by building this data lake, what practices was used, specifically continuous integration and deployment, and several improvements that we identified while building the platform, and we're going to address them in future. So in a nutshell, if we look at the data lake as a main component of the data platform, it may be, it can be expressed as on this picture. So we have something in the middle as a data lake, some kind of compute and storage, abstract computing storage, where we aggregate data. And we take this data from some products, some transactional data, so-called OLTP data sources, and we bring them to the OLAP world. So those two words, I believe, are known to those who are working in data space. And we are aggregating this data in data lake and provide this data for business intelligence in terms of the reporting. We also use this data for data science experiments, for machine learning, and simply just to export the data in more convenient format, maybe to give it to the client, a team, or somebody else in the company. While developing the data lake, so I must say that while this presentation, I will use data lake, data platform as synonymous, because for this client, this was more or less equal things, but I think we all know the data platform is something bigger than data lake. It may encapsulate data lake, but may have much more components. So for this particular story, for this particular client, while building the data lake or data platform, we found that we can easily underline or have a borders between components and identify which components we have actually at the very beginning. So, and yeah, on this diagram, you can see those components as well as the names of Amazon services that we used to build this component. So we don't really care about that much which components we change or modify. We more driven by business, but from the engineering perspective, it's important to know like which component is working with each other or what changes we do where. So for queries, for query engine side, we use Apache Spark, Athena, and Redshift Spectrum. We also have some APIs which we develop within the Amazon Lambdas together with the combination of the API gateway. In order to orchestrate our pipelines, we use Apache Airflow in terms of the MWA service that Amazon has. So this is to manage Apache Airflow. For metadata, we use Glue Catalog. For data integration and data transformation, we use DMS for the integration, and again, Apache Spark for transformation. Classic storage for the data lakes in Amazon S3. And configuration, we also use S3 objects or files, and some configurations also kept in the DynamoDB. And across all layers, across all these components, we use Amazon IAM, and everything is controlled by IAM roles and policies. And also important to say that while developing all this platform more than 1 year, during the year and more, we were as one of the team who were also maintaining this platform. So there is no separate team who is changing this from the developer perspective, or who is promoting some changes to the same team, platform team, operating all of these components, providing the policies, developing new features and new use cases on top. This client is quite interesting because it has more or less global scale, and it represents itself in 3 regions of Amazon. So you can see here that one of the region is US 1, then we also have EU West 1, AP Northeast. So this is the North America, right? The US 1, Ireland, Europe, and AP Northeast, Tokyo, Asian region. So this is about complexity of the deployment. So we have 3 regions, and also we have separate accounts. So if we calculate that, how complex our deployment and how many targets we have, it's basically 3 multiplied by 3. We have 3 environments to maintain, to deploy. We don't have some connections between these environments, like from production to development. That's also a policy there. And from the switch perspective, when we working on some of the environments, so basically, if you are a developer, most of the time you're working on this environment, then there is a specific account, right? So there are 3 accounts with 3 regions. That is why it's 9 environments. So if you're working in the development account, and you can switch between different regions in order to test your deployment. But actually, all deployments are the same. The only configuration is different, and different data sets are deployed in different regions. Now let's start with the main diagrams. So the main data flow can be represented as following. We have some components that we group together, and we call them as data management layer, where those services to aggregate data, to integrate data, to orchestrate the pipelines, to store this data, and add some metadata to our platform. Also, we have query engines to query this data. And of course, we can't live without the security, so we have IAM service everywhere in this layer, right? I already mentioned which services we used in the components right before. They are all listed on the left-hand side. And if we also look on this diagram from a data flow perspective, right, from where the data starts and move to where, what's the destination. So we have those data sources, like today they are mainly RDS instances, Postgres databases. This is the current use cases, but there could be also future use cases where the data may come directly from some S3 bucket which is maintained by somebody else, by another team who's sharing data to us to be aggregated into data lake, or some kind of message queue. So once data is integrated or extracted from the data sources by DMS or maybe by Spark directly, it's stored in the S3. We also registered into the Glue catalog. All of this compute tasks or pipelines are orchestrated by Airflow, MWAA, right? So the managed workflow for Apache Airflow. And eventually this data available can be queried by Athena or Redshift from those users who are using some BI dashboards or some client applications, or some consumers who are working for data science services. There's also an interesting layer or component that we've got while building the data lake, which kind of sits on top of this compute and storage components, the API layer. So it's more or less programmatic access for different things. Today, there are 2 APIs that we provide for other teams to call some of the workflows externally. So how does it look like from the Amazon architecture perspective, so which services we use. I already mentioned this, the main code is deployed as Amazon Lambda, and there are two of them today. One of them is called Workflows API and the Custom Columns API. So yes, you see that they're behind of API gateway with specific authorizer based on the IAM role. Also has static DNS record or just DNS record that can be used by other teams or clients to query this API. This API also, for example, if we talk about the Workflows API, shortly, it allows to trigger some of the workflow from Airflow perspective externally, and Custom Columns API allows users to customize the SQL views by writing SQL expressions, and these SQL expressions will be used to generate a SQL view at the very end. And the SQL view will be or can be used by any consumers, and the main target use case is the business intelligence tool that can query the data through this SQL view. So basically, that's the way to customize the final shape of the table that the BI will be using. That's two APIs that were developed for the main use cases, but there, of course, we have in mind the future APIs. So we have some to-dos APIs, like provide the status and health of specific data sets, and they encapsulated in terms of the tenant, which I will uncover later in this presentation. And also to provide some kind of API to add new tenant to the system and or remove it from the system. Let's talk now about the multi-tenancy. So multi-tenancy is one of the main requirements for this customer. So as I mentioned, this is the software as a service company, and they provide this software to other big companies who maintain lots of data about the inventory or stock, some items in the warehouse, and this data can be also used by these customers who are using this whole platform. So the whole platform is much bigger than our own piece, which is data platform or data lake. So this is drawn here as this bigger box SaaS platform. And from our team perspective, so we are a data engineering team who's operating piece of the data lake infrastructure for some of the tenants. So the data lake itself or data platform within the SaaS platform is a multi-tenancy platform. So here we can see that there is some tenant A. It has its own data plus computer resources. And all of this implicitly belongs to some customer, to some company who has made a contract between themselves with this SaaS company. And for us, for data engineering team, means that we need to onboard this tenant to the platform, to the data lake platform, and create something for this customer, either in advance or maybe then lazily when it comes to run the first time this pipeline for this tenant. So there could be, of course, multiple tenants, and they all have the same set of static resources, but the dynamic resources like data sets, or tables, or data volumes that, of course, different per each tenant. What are the requirements for tenancy or multi-tenancy we've got? So they are quite common ones. So we need to isolate tenants' data in terms of the access and security. So we cannot allow users from one tenant to access data of another tenant. So from business perspective, this is one company who doesn't even know that it's also using this infrastructure as another company, or maybe there could be even some competitor. So this, of course, must not be possible to access any other data than your data as your company. And computer isolation. So we provide this software as a service, and there shouldn't be this problem of so-called busy neighbor, where you are running your stack on with some other companies. They should not have this performance issues where they running some heavy loads and affect some other customers. So we need to guarantee that as well. So what we've come up with is some stacks of resources which we are called account resources, common resources, and tenant resources. That's all these layers enabled us, or design of this enabled us to then focus on this, what is actually the tenant-specific resources. So here, resources, I mean all what we create in the Amazon inside of these services, like S3 buckets or IAM roles, or tasks within DMS, or glue jobs, all what you can imagine, all these tasks, all the footprints within the Amazon. It also corresponds to resources in terminology of the Terraform tool. You might know this DevOps tool like Terraform. And it also has all this unit of the configuration called resource. So that's coming from that word as well, but it's kind of mapped to Amazon things which you create as, programmatically as well. So what we have schematically is, if we look at these layers, they are based on each other, right? So the main basement or baseline is the account resources. The Amazon account gets resources which are shared across regions. And then within each region, we deploy common resources. And on top of the common resources, we deploy specific tenant resources. There could be from 0 to n tenants in a specific region. And that means also that account and common resources are shared to the specific tenant resources. We will look at in a second what exactly is shared and what is not shared from a tenant's perspective. So that's another view of the tenant resources, where you can see actually what is shared and what is not. Let's compare this tenant A and tenant B views. So most of the things are specific, so isolated, right, from each other, like glue jobs, IAM roles, S3 buckets, different things like Athena workgroups, DMS endpoints, tasks. This can be easily isolated, so they can be created per tenant. You don't need to really to worry. Thanks most to that all of the services are like serverless. Yeah, all apart from these two which are shared one, like so these are Airflow cluster and Redshift cluster. So we use Airflow, as I mentioned, for orchestration of the data pipelines, and Redshift we use in specific cases for some of the clients who wants to query the data through Redshift specifically, or they have only interface with Redshift, so we provide this query engine. So Airflow, from Airflow perspective, the service which is today, it's not serverless, it's service-full. So you provision specific cluster or specific in-situ instances, and then you run as many workflows as you need, and then you can scale this cluster, right? But in order to create these clusters to isolated per tenant, that would be quite costly. So that's reason for Airflow, actually also for Redshift, that we create a cluster per region, and then we share this cluster to all the tenants sitting within the same region. Then, of course, we make sure that tenants running within the same shared clusters are isolated in terms of the configuration and security access, so they cannot really read its own data, for example, from Redshift perspective. So in Redshift, there is you can have many databases in one cluster, many schemas in one database. So all is controlled by the permissions within the Redshift itself. From the Airflow perspective, it is a bit loose security configuration, but since it's the main tool used by the data engineering team, there is no need so much for isolation between the different DAGs or workflows within the Airflow cluster. Also, it was worth to mention that some of the resources are created lazily. Like if we onboard new tenant to the system, we don't create everything at the very beginning. Of course, there's some static provisioning of the resources to some specific region for a tenant, but then when the first time we run some pipelines for a specific tenant, they create additional things like Glue databases, Glue ETL jobs, different DMS entities that it requires, or AMR cluster, for example. For some of the cases, we, instead of the Glue ETL, we use EMR to run Spark jobs. From configuration layer perspective, how the tenancy affects this layer. So let's look at this diagram as well. So configuration layer is there are two pieces. First piece is this Terraform scripts that we maintain as a data engineering team. The scripts defines all the structure that we need to create in Amazon. And what it does, it first of all creates this all native resources in Amazon. Also, it uploads a couple of business configuration to our space, right? To S3 buckets, special S3 bucket, and to also a special, we call it system resources, some data to DynamoDB as well. And eventually, our configuration is used by Spark jobs, right? So we read this just simply from S3, from AMR or glue job. Also read some system configuration by the Airflow itself when there's some specific DAG or workflow is running. Okay, so that was block about the multi-tenancy. Let's look now on the standard workflows, which we have developed while satisfying most of the use cases for this customer, building the data lake for them. So in order to pull the data into the data lake, you have to have perhaps one or two standard pipelines, which we call them as initial load and incremental load. And so the first day you start some kind of data lake, you need to load all the data that you already have in the organization, right? We also have here multi-tenancy, right? So that means we in data lake, we slowly onboard different tenants, different sub-clients of this client to our world. So we don't need to load all the tenants at once. So that is why all the workflows, all the things, they are tenant aware. So from initial load perspective, we have some client that wants to be onboarded to the data lake, and we just run it manually on demand, this pipeline, and we upload the whole data sets, all the tables for this client for specific product to the data lake. And that's it. So we stop this pipeline. We don't run it ideally anymore. And then incremental load starts right after we finish with the initial loads. It runs 24/7, and it just loads the delta to the system. Also, we have like main pipelines for aggregation or data transformation. We call this pipelines derived table builds, and auxiliary pipelines are from category of housekeeping. So derived table build is some kind of different business SQL queries, which using already data which is already in data lake, aggregating it, processing it, and creating special shape for these data sets to be consumed further by BI tools, for example. And housekeeping are those special auxiliary jobs which are only needed and maintained by the data engineering team, and they are optimizing storage, mainly the deleting all data. So you gotta have this type of jobs anyway in the production system to maintain it over the time. Now let's look in detail. So how we've built the initial load from the workflow perspective, and also how the steps are mapped to the Amazon services. So we'll go through all four types of the workflows we have. So what we have here is the two Airflow DAGs. And the first part, the first DAG for initial load, it just spin up the DMS task. And this DMS task is doing actually the main work at loading data from database, from RDS database to S3 in Parquet format. So this DAG is running on its own, and it's implicitly connected to the next DAG, but they are like not aware about each other. They're just shown on this diagram that they make sense. They are part of the same picture, or the bigger picture. And the second DAG is taking the uploaded data and registering it in the data catalog, and also optionally can already prepare the derived table. So can already prepare some aggregates for the future use by the BI tools, for example. I probably also need to say that we use some technologies here like Delta Lake, which I'll uncover in a separate block also during the presentation, which is we take the data and register in the data lake tables. So that's also important thing to keep in mind. Incremental load is very similar to the initial load. So if I go back, right, so to initial load and then again to incremental load, you see the pictures are very similar. The only difference is that incremental load this time starts the ongoing and continuous task in DMS here, and the DAX is just triggering that, and DMS is running the task 24/7. And this delta or data are also stored in the S3 bucket as raw data in Parquet format. And time by time, we run this job to increment deltas to ingest the deltas to our main tables. Yeah, also probably worth to say that one of the main feature that we have here in incremental load, or the approach that we followed, is that we already have some data in data lake, right? So we have these deltas that is coming constantly to our system. So in order to synchronize the new data with the existing data, we need to merge this data with existing one. So usually it means so-called upsort or insert if it's missing, or update if it's there already in the target, or delete if the data which is coming to us with the flag delete. That means we need to also delete in our system. Also, over the time, we developed another version of the incremental load using Spark streaming. So I mentioned that on the first version here, it's a batch approach, actually. So here we run DMS continuously. It's giving us the deltas. But further, in order to ingest the data for consumers to read this data, we have to either configure the schedule for this DAG to ingest data to the data lake, or trigger that manually. So next version, evolution of this incremental load pipeline is to split the second part into two parts. So now we have kind of 3 DAGs for this global picture, or bigger picture of the incremental load pipe workflow. And the next version of the incremental load for the Spark side looks like this. So we first we change the ingestion from batch to streaming job. So we constantly pulling the files from S3 and merging them to the data lake table. That's just a standard feature of Spark here used. And then we extracted the part where we build derived table, which needs to be triggered still on a schedule or on demand by users in order to create new aggregate, a new BI report when they really know that, okay, the data probably already came there and they need to new version by next morning, for example. So second part is not really feasible to do in the streaming mode because of so very complex queries that we have. So basically, it's a graph of queries to be run in some specific order. But also, the nature of the data is not really in this kind of streaming way that you would need to have this real-time dashboard here. This is more or less summarizing what I already described. The first DAG is running a streaming job. The second DAG builds derived tables in a batch mode. Advantages of this approach compared to the previous version, that new data is available in the raw tables close to real time. Disadvantages are that you run the Spark job 24/7, so your Amazon cost or service cost is rising. So there are some options for mitigation, how to do this, how to minimize the cost, perhaps use EMR cluster and try to optimize some instances and maybe share this cluster for other workflow for the same tenant. So there are some already ideas how to minimize the cost. So yeah, that's a whole topic on its own, how to reduce the cost of the Spark jobs in Amazon or any other cloud provider. And housekeeping jobs are very similar. So there is just one Spark job running on demand. There's no need for streaming or jobs like running continuously. It's doing time by time, once a week or once a day, some compaction of that or purging the old data from the data lake. All right, so we are now at the next block about workflow implementation. So how we develop them, how we program them. The main thing we used is Apache Airflow. So the quick facts or reminder about what is Airflow. It was developed by Airbnb, open source in 2016. It also available as several options right now in the market, and Amazon has its own managed version. Important concept in the Airflow called DAG, Directed Acyclic Graph. This is the abstraction that you express your workflow, and you express that only in Python, so only programmatically, which is very suitable for us. By Airflow, we orchestrate many services in Amazon, and I also highlighted them here in this diagram. What is actually those services and why do we orchestrate them? So in order to do data ingestion, data aggregation, we use these services or orchestrate these services by Airflow, like EMR, GlueTL, DMS, and Lambda. And we also read some configuration by the workflows, by the DAGs from Airflow, from the S3 and DynamoDB. There was huge work done to support multi-tenancy in Airflow as well. So as you remember, Airflow is shared cluster for this architecture, and in order to have multiple tenants running within the one Airflow cluster, we come up with some naming convention for the DAGs. So DAGs are those workflows which have unique IDs, and you can see them on the pre-spring screen where we have some convention. I will uncover that on the next slide. And that's a requirement from Airflow perspective itself. So we cannot have two DAGs, two workflows with the same name, so that doesn't make sense. The convention is quite simple. So we have some encoded tenant name plus the DAG name, so we call it DAG type. For some workflows or DAGs which are use case based, kind of, we also have additional differentiator in the name, which is we call use case name. So you can see here that the tenant name is price data lake QA. So this is the experimental tenant name. So it doesn't really make sense that much from the business perspective, but this is like transparent ID, the whole name. Then we have use case name called sales history and derive DAG type, derive Spark. That means that this DAG will be built in derive table and it's based on Spark. In order to generate all these DAGs that you've seen on one of the previous screen here, so this is there are 11 DAGs today per tenant. So every region may have maybe 20 tenants. So we will have more than 200 of DAGs within one cluster. And we don't want to copy paste the same DAG code to every tenant, right? So Airflow allows us programmatically also to generate DAGs. There is a specific import process in Airflow, and we've come up with some configuration in JSON format, which can be used, which we using to read it during the import time, and we generate programmatically the DAG. So basically, we have a couple of Python files which are programmatically generating hundreds of DAGs, and that's actually, it's not, so if you know the Airflow, it's not that we have many 200 files of Python or just one file, but it's just creating the objects in memory, which is then used by Airflow to create these DAGs in its own application. So this configuration shortly looks like this. We have an array of objects where every object is a tenant definition. It has some properties. It has some scheduling properties for types of the DAGs, and also for DAGs for use case-based DAGs. So these are the names of the DAGs, and there could be optional schedule, like cron-based schedule, or no schedule means somebody would trigger this DAG on demand. From a code source perspective, this is the Airflow source code we have. There are different files. We have also structured these files per product. So this customer that we developed Data Lake for has specific product, about 6 to 8 products. One of them is called price. And for this product, we have specific code developed to have these pipelines. They aggregated specific package, but there are not that much code per tenant. So all is quite generic. If we look at the DAGs that were developed by us and then rendered by Airflow, we can see that there are quite complex one for DMS pipeline orchestration. So in order to run something DMS, we made it very small steps to orchestrate all the things in DMS. So this is the DAG for full load. This is the DAG for incremental load. This is only DMS part. You can see that the DMS CDC part or incremental load is much more complex. So it has lots of steps. So it's rather detailed ones. But if we compare with the Spark DAGs, they are quite simple one. The reason is that Spark job is the program that you trigger, right? And this program can be any complexity inside. And from Airflow perspective, we just have this command like Spark submit or just trigger this Spark job somewhere in the cluster. But from Airflow perspective, we have just one task. So this is the initial load DAG where we trigger 2 jobs like ingest data and derive tables. Incremental load similar, 2 steps to 2 Spark jobs. For streaming option, it just split it into 2 different DAGs. So a DAG with 1 task only. So they're much more simpler, but this is neither good or bad. So this is just how it went with regards to technologies like Spark, where you write also code on the side for your programs, and DMS, which is just a serverless API from Amazon, which you use in here to create such a rich workflows where you control every simple step here to create different configurations, start the task, wait for task, destroy task. So that's the reason. And for housekeeping jobs, similar. So they are all also Spark-based, just 2 tasks and 2 separate DAGs. Okay, so now we're going to explore some key technology that we used to develop this data lake, and it's called Delta Lake. So Delta Lake, it's a library developed by Databricks, and it's open source project as well. It's part of the Linux Foundation. And this technology, in a nutshell, and compared to what we needed, provides the ACID transactions for data lake, upserts and deletes for Spark, schema evolution, the time traveling feature, so you can have different version of the data in the same table, and much more. Yeah, and it's also, I forgot to say this, it's a main target runtime for this library is a Spark, Apache Spark itself. So we're using this library within the Spark jobs. And also, it's worth to mention that the whole idea of the Delta Lake library is to enable so-called lakehouse architecture. So what is lakehouse architecture? You may find much more information on the Databricks website. They are basically found this name and terminology and the whole architecture and movement. But what they say is that we know what is data warehouse, right, and what is data lake, which can be represented in a way that in data warehouse you have some ETL process that extracts data and stores in its own storage, and then allows BI to consume this data. A data lake, we have 2 things, so like a data warehouse as well as the data lake itself, the files, the blob storage, where we use 2 things for different use cases, one for BI, one for data science, machine learning. A data lake, lakehouse, it's kind of a combination of 2 worlds where we have all the nice features of the data warehouse plus data lake itself, cheap storage, cheap compute resources, and all of the whole data lake plus specific technologies are now called Lakehouse with the data lake library, and that allows you to provide the data to all the type of the consumers. Before choosing data lake for our data lake story, for data lake implementation, we also compared that with Apache Hudi. So for somebody who's interested in the Apache Hudi, this is what we found as a strong and weak sides of Delta and Hudi. So both are fine. They could meet our requirements with regards to the transactions and merge operations. However, Delta showed better results and better performance, and also better quality in terms of the documentation and the runtime itself. So we've chosen Delta Lake, and we did a lot of tests in order to switch or just focus on Delta Lake itself. A bit of information on how to query, how to use Delta Lake in Amazon. So it's not natively supported, like, for example, in Azure. So in Amazon, you just do a simple trick. So you use that as a library within your Spark job. So you just need to have this library on your class path of the Spark job. So you can just in advance upload it somewhere like to S3 and then use the path to the jar in your Spark job. In order to read the data from the Delta Lake table by Athena or Redshift, it's also one more trick. So there are like so this is the main trick, and the trick for using the Delta Lake as a library, just standard approach how you use any library for Spark, right? So this is not really specifically to Delta, but this one is about to query this Delta Lake tables by services like Athena and Redshift by Amazon. There is official recommendation or workaround how to do that, and it's in a nutshell. We just need to create additional symlink table which will reference the whole data via manifest file. And in order to do that, we just need to apply a few commands. They're also available from a SQL perspective in order to just link this data and then provide it to be queried by Athena and Redshift. So what's going on here? We create the manifest file with the generate command for this table and all the references to the Hive metastore or Lookatalog. And we create one more table, external table, which we reference to this file where all the list of files will be as a links to the main files. And then there are a question like, what if the main table is changing? How do we allow this table, which we create as a second one, to be also updated as well? So there are two options. Either we set specific property on the table that will allow to update the manifest file anytime the main table is changing, or we just regenerate it explicitly. So we went with the option A here, and it works perfectly fine. This data can be queried by Athena and Redshift without any issues. Okay, so with regards to the use case, let me first remind how the whole pipeline looks like in a nutshell across different pipelines or use cases. So we have product database where we copy data to so-called input data folders. Then we register this data, and when we start to call this data as row tables or row data, and then when we do something useful with this data, we call it aggregated. And these aggregated tables, we also call them derived tables. So one of the use cases to aggregate sales data, and it's called fact sales use case. Technically speaking, it's called this v_fact sales. There are other use cases, different price list comparisons, but what I would like to show you is that complexity of this use case and how we implemented it. Here on the right-hand side, you can see like a tree or graph, which shows the path of building the final table based on the root and children nodes. So every blue node here is some SQL view code, and every gray node is a table. So we ingest around 20 plus tables, and in order to aggregate this fact sales view, we first run around 7 or 8 intermediate queries in a specific order, and then we have a master query on the top, which a query several screens long that builds a final flat table like a data mart with 100 columns. So this is the complexity of this use case. And from the data engineering perspective or our team perspective, this is where our story ends. So we just build this table. We also create some SQL view on top to manage those custom expressions for the table through the API, and that's it. That's end of our story or use case. Then the other BI teams are using this data and then add some change requests to this shape of the table. So technically speaking, how we build this final table, we maintain a set of files per each use case with this SQL extension, and every file contains Spark SQL code. Then we also came up with another JSON configuration which describes the graph of the queries to be run in specific order. Every query here on this right-hand side also has some properties like what to do with specific query. But in a nutshell, it allows us to run all these files here on the left-hand side in specific order, and order will be corresponding to this graph. So it will be collapsed from the child nodes to eventually to the root node. Yeah, and also it's worth to say that sibling queries, which are on the same level, will be running concurrently. So we built some small library for Spark that just traversing the files, SQL files per use case, and run them either concurrently or in specific order that guarantees that final SQL query that produces some data frame will succeed. Eventually, we have as an output some table, which we call derived table. It may be quite wide, right? So this particular use case have more than 100 columns. And this table can be built on specific schedule and have some metadata, some tags on top of this derived table. Yeah, we didn't really come up with a proper definition of the data product, but it will be refined. And this is the whole question of the data governance topic, which will be addressed in future. So for us, the data product here is just a table which we expose with specific interface to our data consumers. All right, so we're almost at the end, and the next topic is about continuous integration and deployment. While building whole pipelines, the API layer and Airflow code, we came up with some Git repository, which we call Data Lake Core, where it contains almost everything. So we may say it's kind of monorepo that producing some artifacts as binaries or the packages to internal JFrog Artifactory system. And then we have different product teams which also started to have own kind of data sub-teams, which we train and show how to use the code for them. So eventually, it's not really something like a data mesh that you may heard of, organizational structure, but it has some traits from this organization structure. So every product team then consumes our code through Artifactory as a binary dependency, and they also can build their own Spark jobs and then create a workflow pipeline and schedule on our infrastructure. From CI/CD perspective, that's a schema that used implemented by our team, but it's quite the same for other teams. So for continuous integration, whenever the data engineer changing something in Git, so in our case that's Gerrit, it's every change to a specific branch triggers the Jenkins job that compiles the code, runs some tests, and that's it. So this is one flow with this left-hand side flow, right? It's a change, right? It's this color. And another one is this, like a light green color, is about to release a new version to the Artifactory. So that the command called git tag. So once the engineer tags the specific Git state, it triggers another Jenkins job, and then we have new artifacts in JFrog Artifactory. That could be a new version, good to be deployed, and there is some agreement or somebody would be notified that we're now ready to release new version. And usually it's the DevOps engineer within our team who is doing the next step of deployment. And so how this flow look like is, again, it all starts from the Git perspective, and we have another repository here which contains all the Terraform scripts. So that core monorepo doesn't contain Terraform scripts. These Terraform scripts are in another repository, and Terraform scripts here representing the whole deployment of everything what we have, as well as the new version of some core code or pipelines and other things. So first, the DevOps engineer was asked to deploy a new version. It's he or she was notified with a new number, with a new version number. So they changed this. They use this number in some specific file. They commit this file to Git, and then they trigger the Jenkins job. Jenkins job identifies the new commit in Git, and it starts to run the deployment job. Since this new Git commit, where ideally the last Git commit contains this new version of the system that needs to be deployed. In the same time, or right, it starts. Once it started, it pulls the new artifacts from Artifactory. This is how we link everything to the release flows before, right? And then end step of this Jenkins job. So all it's doing within one job. It's applying new resources and new artifacts to the Amazon environment. So there is, as I said, 3 different accounts and 3 regions per each account. Okay, and one more slide about tenant onboarding procedure. You probably recalled I mentioned at the very beginning that we have processes like tenant onboarding and tenant offboarding, where we first add some kind of customer to the data lake. It also has own Jenkins job. So first of all, some product manager has to come to us, say that we need to onboard this tenant C, and usually a DevOps person running specific Jenkins job with input parameter, and this Jenkins job creates almost everything. So it creates specific users for source database, creates additional credentials in the secret manager in Amazon. It also runs Terraform scripts to configure the common resources, to configure the tenant resources. And in maybe 30 minutes, you already have completely deployed tenant and specific region. And the last topic for today is about data lake improvements. So we were developing the whole platform, I think, during the 1.5 years. And of course, there was some priorities, and some things were with high priorities related to the business use cases milestones, but some things like optimizations and engineering things were on a lower priority, but we're taking the optimization, of course, time by time. And what we found that some optimization also makes sense on top of this architecture are mainly related to operations and the cost optimization. So we don't want to spend much more time sitting and monitoring this pipeline. So the idea is to automate the tenant onboarding and offboarding procedure completely. So the new tenant needs to be enabled very quickly into the system. The monitoring itself needs to be improved, although we have Airflow UI there, right, and different Amazon UI services, but it's not enough. So it should be some kind of ops dashboard, perhaps developed specifically for this project. So we need to optimize some input formats to go from CSV to Parquet at least. The whole data cataloging area also requires some improvements. So today, offering from Amazon Glue Catalog is quite, I would say, poor option. So on the market, especially on the open source market, you have much more structured solutions for data cataloging that you might deploy as your own deployment in Kubernetes. Also, from cost optimization perspective, so most of the heavy lifting jobs or pipelines, which are constantly running time by time, Spark jobs. So we found that using only Glue ETL might be quite expensive option over the time. Also, shared service like Redshift, perhaps one of the expensive services today for data space on Amazon. And the reason why we use it is that our BI tool of choice is working fine with Redshift, but not working fine maybe with Athena or something else. So that's also a bit of issue with that. And the idea is to try to find some maybe another BI compatible tool, or maybe some connector in the middle, so which would simulate the Redshift or something like that. That would allow us to get rid of Redshift completely from the picture. That would also reduce the cost significantly. That's the main improvement. So I think that's it from my side, and thank you for your audience.
Yeah, thank you, Alexei, for your presentation. Fortunately, I can see you. Yeah, I have, it's too dark in your room. Yeah. So
Okay, let me try.
Yeah.
Make it a bit
Okay.
lighter.
Yeah, I have very interesting presentation. Yeah, I have enough questions with you to discuss. So first, yeah, you mentioned about Airflow and that is shared between tenants. Yeah, so how have you actually split the access between tenants for separate DACs? Because as far as I know, so dashboard is single. So do you mean that all tenants have access to all DACs?
Mm-hmm. Yeah, it's still we can see all the DACs from all tenants at one Airflow cluster. Actually, we didn't need to split the view or access because the only data team is working with Airflow. There is no customer who is working with the Airflow on its own. That is why we could afford ourselves to just to not isolate that within one cluster. Otherwise, we would have to deploy a cluster per tenant, or maybe even think about different solution than Airflow itself.
Mm-hmm. Yeah. Also, also, could you please share more details about these tenants? So you mentioned that each tenant has same resources. So do you mean that they all have same version of platform? So did you have to manage different versions in separate tenants?
Yes, good question. So maybe let me just come back to the slide of this resources separation. So actually, there's 3 layers where every region gets common resources and the tenant resources. The count resources are something that is very small, and mainly because of some services require some IAM policies which cannot be copied from one region to another region within one account. So let's remove the account resources from the picture. What is left is common resources and tenant resources. The common resources are we call them also system resources. Those are like APIs which are not tenant-based, like those lambdas, or some system buckets in S3, our code itself, shared clusters like Airflow and Redshift, and many other things, mainly configuration to IAM, which makes sense to deploy for everybody within one region. And now coming to the last layer, the tenant resources like again, IAM policies, specific S3 bucket for this tenant only, and some different configuration for this tenant only. Yeah, and the versions, how do we maintain versions? So I'm not sure if you work with the Terraform in general, but whenever we change something for common resources or tenant resources, we rely completely on this tool in Terraform, which is the infrastructure as a code tool. And if it detects some changes that, for example, tenant bucket has changed its properties to now have some specific access, it just identifies this upgrade automatically, so that we don't really need to upgrade some resources to specific versions, happening automatically, again, thanks to Terraform.
You mean that you didn't have to manage different versions of this tenant resource, so
right,
for different tenants?
Right, we didn't have to do this, and also, so we have the common resources at the system level, and we upgrade the whole system for all tenants at once. So we don't need to have different things for different tenants. However, if we really need some kind of different behavior for some tenants, or something like that, then there's only single place where it's actually was requested. It's on the level of workflows, on the level of the business code. Those derived tables, for some tenants, may have different requirements, or they sit on all the schemas of the product, of the data that we take in as a source. There we just come up with different code in different folders, and that corresponds to some version that is coming not from us but from the source system. This is the only single place where we may have to have different versions, but that again, not those changes are not like among the tenants, they are more among the version of a specific product. So our system depends on the data that is coming to us, and that was the requirement. But eventually, we've come up with quite generic system, and you've seen during the slides I showed a couple of JSON files where they're used as a configuration, and eventually, yes, you can say this tenant has to use this version of the business code, and so it's a lot of configuration parameters where you can override behavior of different tenants within a region and within account.
Yeah. Also have a question. So what problems did you have, or maybe you solved during creating multi-region platform? So, for example, I don't know, I've noticed that you have maybe single, multiple JFrog. Maybe you have some problems with accessibility between multiple regions. Oh, by the way, why did you have to create multi-region platform? Is it due to resilience, or so what's the reason?
Yeah, I got the question. Yeah, it's really an interesting question, because actually, if we could, we wouldn't create this multi-region or multi-region deployment system, because it's lots of work. It's also lots of operations, even though the deployments are very similar. So, but the reason is because of the business. So this company for whom we build the data lake, operating, as I said, in these 3 regions, North America, Europe, and Asia. And they are contractually obliged to keep the data in those regions where the customer actually based on. So, for example, if we deploy, if they sold a product for a customer from Europe, eventually this customer can also be upsold to have a data lake service. Their data also needs to be in the European region as well. So we cannot, for example, deploy everything, all the computer sources in US East 1 in North America, and serve those infrastructure for European and Asian customers. So that's the requirements, and that's the same for all the regions. So if we deploy somebody from Asian region, they also has to be there. And it all starts from the OLTP database. So those primary products, so applications, which we are not talking about them today, they are also region-based. For example, this company, they install or deploy some client in Asia. They also enable their application, their deployment in Asia. And then we add our add-ons of data lake there to this region. So that is why we have to support all this bigger enterprise architecture here in the smaller kind of footprint of our data lake. So our data lake, as I mentioned, is just the one piece. It's important piece, but the whole SaaS platform that they have is much bigger, so it has more other applications.
Okay, yeah. Also wanted to ask you to share maybe some experience when AWS services wasn't stable enough. Maybe you just faced with some problem with AWS service. For example, personally, me had issues with DMS. Yeah, it wasn't stable, and it wasn't quite informative. Yeah, so maybe something from your experience.
Yes, I agree about the DMS. So it was confirmed by multiple teams during the project implementation. That's perhaps one of them. I just opened the diagram about main flow to show what we've used there. All other services quite simple and stable with regards to usage or issues. We don't really have any problems. With regards to DMS, it's a not fully serverless service. It has some EC2 instances that you need to choose to run the ingestion task. But when it's running, it's kind of invisible. but in order to first time make sure it's running smoothly for your database, for volumes that you have, you may have some different errors out of the DMS, saying some errors, they are not really readable. And we have to have several request tickets to Amazon support where they really told us what to do, what to change in our configuration to avoid those errors. Sorry. So that was lots of time spent there. But eventually we've made it work, and it works fine eventually. And we know where we shouldn't perhaps use it for future, and what to avoid. So we kind of learned also how to use it. Other services, perhaps GlueTL, you might know it's a serverless service, which you just submit a job and you specify how many workers you want to have. I would say if I compare GlueTL versus just EMR Spark jobs, GlueTL a bit harder to debug because you have all what you have is this CloudWatch logs, and you need to read them in a bit inconvenient way. Most of the issues are first time related to IAM policies, that something cannot be read by a GlueTL job. Then, so it's a bit much longer to make it work first time than just EMR job. Also, login is a bit different than in EMR Spark jobs. That perhaps another one that added a bit of headache, but that's much lighter than DMS was.
Got it. Also have a question regarding this Delta Lake and Delta tables and Hoodie. As they support each other, so can I just switch between, for example, between Delta Lake and Hoodie, or I need to reload everything?
Well, so let me maybe just open one comparison table there. So actually, they are not really depend each other, but you can migrate from one to another. I don't remember exactly about the Hoodie, but both technologies, they have manuals how to quickly start with them. So usually people come into Hoodie or Delta Lake or Apache Iceberg, or maybe some additional new libraries pop up this year. I'm not sure. They're very fast to grow in this space. You start from some kind of Parquet data, maybe CSV data or so, and there are some receipts how to change your data format into the Delta Lake or a Hoodie. And same from kind of migrating out of it. Similar manuals exist for all of them. So if you'll end up using Delta Lake for some time and you don't want to use it anymore by some reason, you just export this data into the Parquet, or even just use an additional code into your Spark job to just read this data as a Parquet, not as a Delta Lake. And so I must say that migrating to and out of it is quite easy. So you just would need perhaps to run one-time job to migrate all this data. And some of these technologies like Hoodie or so, they provide even kind of automatic upgrade. So you just run some job that it will discover again, okay, this folder is not Hoodie-like table, it will register as a Hoodie table. So all of this technology, they are coming with design how to allow users or data engineers to easily onboard onto these technologies.
Okay. Thank you very much, Alexey, for your presentation.
You're welcome.
It was really interesting.
Thank you, Alex.
Hello everyone, and this is Winter Data Meetup, and our next speaker is Alina, and she will cover very interesting topic that I haven't heard before. So it's software development services. Yeah. So please, Alina, floor is yours.
Hi, hello everyone. My name is Alina and I am data engineer and I did my journey through on-premises solutions to cloud solutions, and it's not only changed in the way how it worked before, like I mean when you think about physical resources you have and licensing, to the model where you think about software as a service. So, and a part of this shift between CapEx and OpEx is um, mm, cloud development tools, which I want to introduce here today. So, as you know, modern applications are a type of a mix of different languages, different computing resources, and different services. So it's really hard to understand how they work. And that's why the main challenge in software development process are projects its uptime and its consistency. Due to this complexity, it's hard to onboard new people, and yes, cybersecurity is a must as well. And yeah, I'm gonna walk you through some features and benefits of cloud development environments. Um, our day-to-day job is when we do our day-to-day job, first we think about clients' needs, help them to accelerate value from data, and that's why time is always matter for us, and the longer it takes to bring the data by developing pipelines, product applications, and deploy them to production, the longer it takes to see the value of our job. So I've examined two different cloud development environments, GitHub Codespace and brand new just launched AWS Code Catalyst. And in between these two tools, there are not many differences. They both have blueprints, so templates for different projects. A bunch of EDs you can use, direct connection to GitHub, and the ability to collaborate with the teams. So I decided um, not to uh, not to explore the difference between the tools, rather to walk you through difference between cloud and local development tools. So, and first, how the project usually start is with setup of development environment. And first, when you work locally, first you install needed runtimes, install editors, then configure them, configure Git connection. Here, when you have an account in the environment, you just can click the button, create a space, and it will show you options you can choose and create it in a couple of clicks. Yeah, so the next thing after you set up environment is set up new project. And once again, you need to download the code from source repository, ensure that all dependencies are stable and work fine. So here you don't need to do these manipulations. You just can click again button and just build a project through existing repository or with a template. And evaluation of the project, the develop of new feature. As locally, you always pull latest version, then create your own branch, ensure that everything's set up for this particular task, everything is set it up, and then you start your work in cloud development environments. You just can click on IDE you like, and it will open a new tab. Yeah, it's all about the process. The last but not least, the security. So we should keep not only data secure, but the code as well. And these tools, they are built with the security in mind. And the good thing for us, and especially for administrators, that a vendor maintain encryption, environment isolation in compliance with data regulators like GDPR. In these code spaces support different roles. Administrator role, where you can invite new administrators, other team members, and delete or create projects. The contributors, in other words, developers who can contribute into the project, and project members who are just viewers who can see what the list of projects and the list of users. Yeah. And to sum up, modern development environments help to accelerate the setup time it takes to create development products and applications. It helps not only start easily, but to evolve the project easily, and makes it easy to manage the developer desktops, work remotely, and collaborate. And if you are interested, you can use this link to get more about environments, cloud environments. Thanks.
Yeah, thank you, Alina. Very interesting topic. Yeah, and these like services that I actually haven't tried. Yeah, but we have a few questions. So you mentioned that it's like a real IDE, that, for example, IDEA or Eclipse that on my machine. Yeah. So, and what programming languages are actually supported? Like, do you know, maybe there are some limitations or some, yeah, can I use Java, Python, and I don't know, JavaScript there?
Yeah, sure, because it's just editors. You can choose any language you want. I've seen templates for Node.js, for example, but it's because its interpreter can interpret varieties of different languages. Yeah.
Yeah, and also you mentioned collaboration. So what do you mean on it?
So it means that you can work in real time with another developer. It's shared space, and you can both like work on it in parallel. And it actually helps when you were stuck on the issue and you call your colleague and you work at exact same thing, and you don't need to share a screen in Teams, because sometimes there are no options to give a control. Here it's more easily and offensive. Yeah.
Oh, that's interesting. So, so is it just so looks like it isn't just a common Git branch that is shared among a team. So you can just, so how does it look?
So once you click on the link, it automatically create a feature branch for you with its own like unique number, and you can work. And if another user has access to the project, you can send the link, and you can both work together.
Ah, okay. And yeah, also Forgot my question. Okay. So yeah, looks like it's an interesting topic. Yeah, thank you very much for investigation of the services. Shared with us your experience. Yeah, thank you, Alina. Yeah,
Thank you.
and I want to invite everybody to our last talk today from Tracy. Yeah, very interesting topic about data strategy. So yeah, please stay tuned. We'll be back in 20 minutes. Hello everyone, and this is still Data Winter Meetup. And next speaker is Tracy Powers, and she will tell her interesting story about data strategy. Tracy, floor is yours.
Great. Thank you, Alexander. Greetings, everyone. I'm Tracy Powers, and today I'm here to share with you the value of the data strategy articulation map. I confess it's one of my favorite topics. As a brief introduction to me, my career spans 30 plus years in data management, data governance, and data strategy. My experience includes technology consulting, business transformation, and strategy definition. For our time together today, we will make the assumption that all businesses have a business strategy. It may not be formally written down, but directionally, there are goals that executives have agreed to accomplish within a specified time horizon. What we will cover today is a need for the mapping of data to that business strategy to succeed in today's world. We've all heard over and over, data is the new, fill in the blank, was oil, now it's bacon. Not sure I agree with bacon, but anyway, yet many companies are merely gathering data and not monetizing it. How could that be when everything is spooling off reams of data? Just think, your phone, your car, now even your refrigerator. Recent publications show that there's often a disconnect between data strategy and the business strategy. Personally, I love this quote that only 30% of organizations have aligned their data strategy to their business strategy. This would clearly indicate a misalignment of business goals and the ability to meet those goals using data. What is much published today is the lack of value, either real or perceived, from a data strategy. This also indicates that a data strategy exists, but there's no mapping to the realization of business value and potentially a lack of adoption. Lastly, let's talk about change. Everyone is inherently resistant to change. We all know that quote, but why? When executing a data strategy, there are often new skills needed, which can bring an element of fear of the unknown. There is the fear of, what will I need to know? How will I find more time in my day to learn new things? Does my staff have the skills to do new things? How do I upskill them while still retaining them? Where will I get budget for more stuff? Throughout the presentation, we will discuss the difference in our approach and how we address each of these three topics from a people perspective. Our approach includes data strategy, data literacy, and data governance paired with communication and organizational adoption. The results will not only assuage fears of the unknown, but create demand for transformation to a data-driven culture. Before we go further, let's anchor on our definition of a data strategy because it may be different than yours. In the diagram, you will see how a data strategy encompasses business goals, plus data management capabilities, plus analytical capabilities. It's the intersection of these three elements that define a successful data strategy. The process of a successful data strategy adoption begins with executive and stakeholder alignment and the shared vision definition. This is the first critical step of bringing the business stakeholders together with the technology stakeholders to discuss the needs of the business in business vocabulary, or we often refer to this as the North Star. Next, we move on to the assessment and roadmap to take inventory of what's working today and what can be leveraged in the future. The framework and operating model take into consideration how the future state will serve the needs of the business. An important component here is future scalability. Organizational capabilities drills deeply into what skills are necessary in the future state, what data literacy is needed, what skills are missing, which roles can be upskilled and leveraged. Lastly, the value and metrics enables the measure of value received from the data strategy. These metrics will change over time as increasing levels of maturity are realized, but they are critical indicators of data strategy adoption and the business value generated. Now that we're aligned on what a data strategy is and why you need one, well, now what? Before we go on, let's talk a little bit about why data strategies can fail to generate the expected value and outcomes. Let's review a couple of the pitfalls. First, lack of clear goals and objectives. A data strategy must have clear goals and objectives that are aligned with the business objectives. Without a clear understanding of the goals, it's difficult to create a strategy that's effective. Lack of buy-in from key stakeholders. A data strategy is only effective if it's supported by key stakeholders, including senior management and other decision makers. If there's a lack of buy-in or support, it can be difficult to implement the strategy effectively. Third, insufficient resources. A data strategy requires significant resources, including data scientists, technology, and infrastructure. If these resources are not sufficient, the strategy may fail to achieve its objectives. Inadequate communication. Communication is critical to the success of a data strategy. If the strategy is not communicated effectively to all stakeholders, including employees, customers, and partners, It can lead to confusion and resistance, that fear that we talked about a little bit earlier. Failure to adapt to changing circumstances. Data strategy must be flexible and adaptable to changing circumstances, including new technologies, market conditions, and customer needs. The strategy is rigid and inflexible, may become outdated and ineffective. Lastly, lack of focus on business outcomes. A data strategy must be focused on achieving specific business outcomes, such as increased revenue, improved customer satisfaction, or greater efficiency. If the strategy is too focused on technical or data-related objectives, it may not deliver the desired business outcomes. Enter the data strategy value chain. Many companies are adept at solving technology problems, and often they jump right in there without truly digging into the business use cases that will be the most impactful to the business strategy, and then pairing that with what technology capabilities are needed to satisfy those use cases. The new result can be that the technology may serve a specific problem, but may not solve all the problems. And a side detractor could be that business users could be alienated through a lack of partnership from the lack of being consulted and understanding their specific needs. Finally, it can still leave gaps that continue to get solved with Excel. When you drive a business strategy top-down, simultaneously building technology capabilities bottom-up, you are able to take information to insights. But this is driven by business engagement to bring the right technology solutions to bear. Sitting in the middle is the data strategy articulation map to tie the top-down business strategy to the future state realization of business value from the bottom-up technology capabilities. As we will discuss next, our methodology to create the data strategy articulation map also solves for the following potential failure points. Excuse me. Lack of clear goals and objectives, lack of buy-in from key stakeholders, insufficient resources, inadequate communication, and a lack of focus on business outcomes. Next, we'll talk a little bit about our approach. The approach to create the data strategy articulation map blends 4 unique phases to create the resultant map. In each engagement, some of the components you see here may already exist, but this shows the overall framework and pieces needed to complete the map. Note that each pillar has a defined outcome that translates to a component on the data strategy articulation map. The key activities are engaging with business stakeholders. I keep saying that over and over. This is done through workshops, branding exercises, and listening sessions. The goals of these activities is to really listen to what opportunities may exist that have not yet been capitalized on. These engagement activities create the use cases for the future state. Now, one thing I want folks to be aware of is there can be a separate activity to define a prioritization matrix that can be used for use case execution at a later stage. The approach and methodology translates into a journey map. The journey is to produce, this diagram shows that the interwoven components that create the articulation phase of the data strategy over the journey. As I mentioned in the beginning, the first step of the data strategy is stakeholder alignment through workshops and interactive sessions. This helps to gather pain points and opportunities and use cases that can be prioritized. But how do we get the stakeholders to speak the same language? How do we get everyone to understand the classic, what's in it for me? The journey you see here enables stakeholders to communicate openly, to select words and phrases that resonate with them, but also encourages them to think differently. The colors of the steps in the journey indicate the purpose of each step. For example, step 2, what are the key drivers for change? For example, the technology in use today may have end-of-life issues. This creates an opportunity to look at re-platforming and rethinking the future state. How does this work meet the strategic needs of the business? Does that increase revenue? Create faster time to market? What are some of those key drivers for change in your organization? Think about that for a second. As you move through the journey, the components in each prior step get leveraged in the next. Key drivers for change, for example, ties directly into the current state assessment for the articulation of pain points currently being experienced. This step can gain alignment between the technology team and the business to agree collectively that a path forward is needed. As you continue to move through the journey, the strategy gets defined. There will be a heavy draw on the use cases from the business that satisfy their strategic goals. As the data strategy begins to take shape, it's time to start weaving in those words, feelings, and phrases that will resonate with stakeholders across the organization. This starts with a branding exercise, which many think is really fun. What do you want users to think and feel when they think of the future state? What will work be like after the data strategy is executed? A key part of dialing in the communication is testing. Do you have a group, maybe your existing reporting group, data governance council, some such group that you could test messages with? And during that testing, does the group understand conceptually the intent when you share those phrases with them? Does it resonate? Is it something they would feel comfortable saying every day in their work? As you continue to work your way through the journey, you are creating messages, crafting outcomes, and defining results that will be shared through a communication playbook. This playbook will include items such as an executive walking deck that compiles a succinct set of messages that can be used in meetings and communications to deliver the messages that will not only be heard, but acted on. Let's take a deeper look at the branding exercise. Each company has its own culture, their unique terminology, and style. In order to capture those elements in a common language, the branding exercise is done. Through this effort, words are captured that define the essence of the future state in a way that is comfortable for executives to use daily, but is understood by all people across the organization. It invites thinking differently. How will you think, feel, or act differently tomorrow that you're not doing today based on our data strategy? This exercise finds the sweet spot in language that allows you to bring people along in the data strategy adoption journey. It gets people collaboratively talking beyond the technology capabilities conversations. Some questions we ask during these sessions could include, when you hear data informed, what does that look like for you? How do you want people to feel about the data strategy? What words need to be used that are commonly understood? What are the pain points that will be resolved in the future state? For one note on this slide for additional explanation, the top part of the slide shows some of the key words and phrases that will create the strategic priorities. The bottom part of the slide defines how the messages of the data strategy will be crafted. For example, in our communications, they will be playful and fun, but not insulting or childish. The next level of alignment is defining the mission and vision. One example of a mission statement from target retailers: we fulfill the needs and fuel the potential of our clients. Their vision: guided commitments to great value, the community, diversity, and the environment. When I hear those statements, I do picture the Target brand, and that is how I personally feel about their Target brand. Let's look at a couple other examples. Our vision is to become a data-driven organization that uses advanced analytics, AI, and machine learning to uncover insights, enhance our customer experience, and deliver value to our stakeholders. The mission is to foster a data-driven culture that encourages collaboration, innovation, and continuous learning, and empowers our teams to make informed decisions based on real-time data. What do some of these messages look like for your company and your organization? By focusing on the branding exercise, the definition of the mission and vision are woven using words that resonate. If we go back to our top-down, bottom-up approach, the vision is where we are going, and the mission is why we are here, and the strategic priorities are measurements of the bottom-up capabilities that are realized in business value terms. The statements crafted here will bring in those communication elements. Our communication and messages will be inspiring, for example. Also of note, on the right-hand side, you will see the strategic priorities are not technical in nature, but articulate the needs of the business that will be satisfied by the data strategy. For example, the future state capability that will be realized is, as a business person, I can spend less time looking for data I want to answer a question or make a decision. Wow, that's impactful, because now I can spend my time doing more value-added work items. Now, let's tie it all together and see what this builds into. Here you see the actual data strategy articulation map. And hopefully you have seen from the methodology and the journey described how these pieces fit together into a succinct, concise one-pager that says exactly where we are going and the what's in it for me. My time will be optimized through the provision of clean data, through a one-stop shop, for example. I will realize efficiencies from automation. I can use predictive models for decision-making. I know where to invest in employees for retention. I can share my knowledge and learn from others. Knowledge is power, share it. But do be careful here. A classic mistake is to list technology products, tools, or applications. This area is about the business value realized through the technology capabilities, never leading with just a technology tool. Here we are leading with framing in a way that resonates with leadership to show up differently. Your data strategy may be asking leadership to show up as data literate, govern things that they don't govern today, implement new processes. How about engage in defining skills matrices and training plans for employee upskilling and retention, but also to address the fear of what lies ahead. All of these aspects are directly addressing people challenges while still providing an actionable roadmap for technology execution. Finally, to ensure continuous improvement, there are success metrics. These can morph over time, as we said, as the organization matures, but they must be identified and captured up front. The metrics are directly in line with the measuring of the future state outcomes and tied directly to business strategy goals. You can see some examples here that are measurable and trackable over time to show both maturity and improvement. Finally, a roadmap. This roadmap is an extremely high-level example, but it's for use in a communication plan for leadership. The primary point of a roadmap like this is to illustrate dependencies and phases of maturity. The coupling of the data strategy articulation map and the roadmap are the foundations for your communication playbook. Note that the adoption swim lane is completely about executing the communication playbook created during the journey. Now, you will communicate what you are going to do, why you are doing it, and what business value will be received, all in terminology that everyone understands and can clearly hear the what's in it for me. You are now set to realize the value from your data strategy through the use of the data strategy articulation map. Now I'd like to pause here and ask a couple questions.
Yeah, thank you, Tracy. Very, very interesting talk. Yeah, so we have questions from our audience. First is there any case study of a data strategy construction that could be useful as a good example or template?
Yes, we do have case studies.
And yeah, so it's available in EPAM, so it's not
correct. Yes,
public
we do
one?
have case studies that are available within EPAM. This
Mhm.
this methodology and approach has been leveraged many times across multiple clients here at EPAM. So we're happy to discuss additional use cases and value propositions and how we've done this at clients.
Yeah, and I have a question regarding data strategy and how to be sure that we are moving in a proper direction and follow selected data strategy. So, are there any verification stage?
Verification and
If
stage.
it's a proper question.
I'm not sure I really understand the question, but what happens in the execution phase of the data strategy, as we said, is the communication, and that communication will continually evolve over time. So with the metrics and the measurements, you would be consistently testing iterative value that you're receiving from the business through that communication and feedback loop that would be created through that. I hope that answers the question.
Yeah, exactly. Yeah, and also who can be an expert to set a proper data strategy? If so, you told that it's not stakeholders. So are they some data architects, or so who can it be?
Who can be an expert to set proper data strategy if not stakeholders, data architects? Okay, sure. When you are creating a data strategy and you're defining the technology capabilities that need to be implemented, you would have a data architect involved in the team. This exercise here for the data strategy articulation map is to really gain alignment on what is needed from those technology platforms, whether it be one ubiquitous data pipeline, for example, that everybody can ride on. Things like that would come in to play when you're talking about the execution phase of the technology capabilities and the needed platforms. You would certainly have a data architect in there, most likely in some of the earlier phases, to understand the data movement that would be needed to satisfy the use cases that are defined by the business.
Mm-hmm. Yeah, and maybe you can share some books or blogs where our audience can read more about data strategy itself, or can learn this topic.
Oh, yes, I'd love to share the slides after this. And, let me look for a few resources. I would be happy to share. I know Gartner has published a lot of articles around data strategy. I don't know that I've really seen anything in particular around the data strategy articulation map. There may be something about it just to reinforce that the value of the data strategy articulation map is really coupling all of those factors together, which is communication, its stakeholder alignment, its mission and vision, all to make sure that you're getting everybody in alignment, singing together, right? Holding hands and saying, oh my gosh, this is the right path. This is what we have to do. This is what we need. I know where I need to plan to upskill my team in order to start using the new technology capabilities and things like that. So the articulation map really includes a lot of the communication, the branding, and then the facilitation and executive stakeholder guidance to get to those messages that will resonate. Then the future state will begin from a technology and capability execution perspective. I hope that answers the question.
Yeah. Thank you very much, Tracy. Yeah, thank you very much for your presentation. Very interesting talk. Yeah, we will share the presentation together with the material that you will provide. So thank you very much, audience, for coming today to our conference. Thank you all who stay with us all the day. Yeah, tomorrow we have a second day of our data winter meetup. Yeah, thank you very much. Thank you, Tracy.
Thank you,
Yeah,
everyone, and a big thank you to my partners who helped me create this presentation. Thank you all.
Yeah, bye.
Bye-bye.